Thank you.
So welcome everybody. Got a nice crowd tonight. We've got Kirk in Canada, and then the rest sprawled across the world, from South Africa to India to the United States of America to Europe, and Australia. So it's really the whole world is coming together for this one event to listen to Kirk Pepperdine tell us how to solve Java memory leaks.
That's weird.
If you have not set up your environment, do it if you can now quickly. So just make sure you've got Java 8 installed. The demos could work in Java 11, but you need to change some flags. It's not worth it. Just use Java 8. That's what most people use for production anyway. And then once you've done that, make sure you've got the Visual VM 142 that I sent you the link for. And then also we want Eclipse memory analyzer tool, or something like that. MAT. And I've sent all this in an email. There's also the slides you can download and the more instructions. But if your tools are all ready, it's going to make it much easier to follow in the exercises. All right, Kirk is just getting set up. If this is your first time with GoToWebinar, it's fairly easy. You just have you can either look at the faces, or you can swipe and look at the screen. Once we start, I'm going to take my video off and mute myself.
Yeah,
because
I have
I'm not
IntelliJ
the guy
giving me
interesting at this point.
Heinz?
Yeah, Kirk?
I have IntelliJ giving me some grief here. It went into full screen mode and I can't get it out of it. Why is it doing that?
Yeah, just do like a 3-finger swipe on your mouse pad to go to. Well, I've got another idea. Just shut down IntelliJ altogether.
Yeah, when I
all the
restart it, it
projects.
comes back up in full screen mode. And when you take it out of full screen mode, it decides to.
Right. So questions. William Paul wants a call-in number.
Excellent.
You know, I didn't set up. Oh man. I can't
No, there is a call number with there. It's.
Is there? I don't
yeah,
think so.
it's included in the email.
Set it up. I didn't set it up. I didn't set up a call-in number.
Huh.
That's a great pity. And the problem is that we actually can't change that setting whilst we're running, whilst we're busy with the webinar. That's a real pity. If you told me beforehand, I could have provided one. But I think it's too late now. Let me just double check that.
For some reason, IntelliJ is giving grief here. I don't know why.
So, yeah, I can't change that. So if you have any questions, there's a questions tab at the bottom. You can open up and you can type in your question there. I can also unmute you if you like. That's quite possible. But we don't normally do that because, well, unless you've got a longer question that you want to ask, of course, we're happy to unmute you. But quite often it's difficult for people to unmute themselves in the environment they're in. So we're going to start in a minute. I'm going to start on time because there's a lot to look at, and we did this workshop before, and we ran out of time. When I first told Kirk I want to do a workshop on only memory leaks, he said, I'm going to fill up 4 hours of that stuff. And last time he could have easily filled up 6 hours without a problem at all. So there's a lot to say. That's why I don't want to talk for too long. We're going to start pretty much on time. There's also, with this control panel, there's also a little hand icon. You can put your hand up if you want to. But we're not really going to be using that too much.
Interesting.
Kirk, are you ready, my friend?
Yeah, I'm just ready. I was just having like IntelliJ give me some grief here on one of my demos for some reason. You know, it's one of those things that works until now, and it just stopped. It just stopped working, and I just wanted to have it set up before I start the slides. And then you know how these things go, right? It's just sort of like really weird. And for some reason, IntelliJ is just giving me grief when it says to open a project, and I don't know why. You know, it's just one of these things that happens, I guess, because it opens the project.
Yeah, once you go into presentation mode with IntelliJ, and you've got multiple projects open, it gets confused. So what
Yeah,
you
I
do
didn't
is
go
you
into
shut down your.
yet. It just but the project that I have opened actually just does not show up at all. But I'm going to
talks and
I'm going to just create a new project here very quickly, and then we'll be on our way here. Sorry for the small delay. It's really kind of funky. Everything is here. And yeah, excellent. It seems to actually be working now, somewhat. Not sure what happened here. Okay, well, okay, so I'll get going, and when I get to the demo, it might take a second longer just to properly get it configured, but we'll go through it with it anyways. Do I need to get my screen started here?
Let me just do a quick formal welcome, Kirk.
Yeah, sure, absolutely.
All of those who are here, and see a nice long list. I won't name your names. It will actually take too long to get through all the names. Thank you for joining us. Thanks for being with us.
Yeah, really, thank you.
Very much appreciated. And this control panel for GoToWebinar is not too hard. I think you'll figure it out. The one thing to know is that when you should now see if you're on a PC or a Mac, you should see Kirk's screen, which says Java Performance Tuning, and you should see Kirk and myself at the same time. You can of course configure that if you want to. If you're on a tablet or an iPhone or something like that, or Android, then it might only show our faces, and you have to swipe to see the screen as well, so or the screen. So there is a screen which you should be seeing as well. Kirk,
right.
Over to you.
Okay.
Bring it home.
Excellent. I know there's a couple of questions in the channel already in terms of will we use Slack, and no, we'll try to stick to this webinar control panel thing here for the moment. Which IDE are we using? Whichever one you like. This is really not about IDEs. It's about solving memory leaks. And I think the other ones are all about the call-in numbers and stuff like that. So I think we're covered off with questions. Just pop them up there. Eventually, either Heinz or myself will see them, and we'll be able to answer them, and hopefully everything will go well. Yeah, so when Heinz first mentioned that, oh, I should turn off my webcam. First, I can wave at everybody, say hi. Thanks for, as Heinz said, thanks for attending.
Why don't you leave it on for a bit, if you like.
Okay, it just confused people last time, so we
make sure you unpause your screen share, Kirk.
Sorry?
Make sure you unpause your screen share.
I thought I had done that. Where is that?
I don't know if you have. Maybe you have.
Oh, it's still paused. Okay, so it's a show. Okay. Okay, so the first slide is just the title slide, so it should be good. And for some reason we're jumping around here. Okay, anyways, so let's get going. So yeah, so thanks for everyone for deciding to take this. I hope that it's informative and will help you in your next memory leak hunt. And you know, as Heinz mentioned, when we first started talking about memory leaks, he was going like, oh yeah, I think 4 hours should be enough to cover the topic. And I was going like, really, 4? And then when I put it all together, I realized there was a lot more to talk about than I anticipated. And so I want to try to get through the talking quick so we can get hands-on, because I think that's where the real value is in this whole thing, is just we'll get some techniques, and then we'll use the techniques to actually, yeah, you can try them out yourself just so that you feel comfortable with them. Now, I mean, the problems I have will be not small enough so that you could sort through the source code and read it to find the problem. So you will need the tooling, but it's not big enough. Like it's not like a messy production environment also. So, you know, so it's on the smallish end. But that said, the techniques, we've used them in all kinds of different environments, and they work very, very well, and they work very, very quickly. So we can find things very quickly. So that's what we'll talk about. It's like, what are these techniques? So in order to do that, we need to talk a bit about technology. We need to talk about tooling. And the thing that I want to bring here to the table is, or what I typically bring to the table is a methodology. And the methodology really says, okay, here's the technology that helps us, you know, that's how all this stuff works. Here's some tooling that's going to help us visualize what's going on inside our technology, our tech stack. And the methodology is basically a way to proceed through a diagnostic, right? So I have a regression, where do I start, and how do I proceed through the entire thing? By the time we get to memory leaks, we've already done a lot of this high-level work in terms of identifying the root cause. And now at this part of the methodology, we're just following what I call recipes, and the recipes here are designed to take you down the last steps in order to find out all of the information you need in order to solve the problem. Right, so memory leak. So I looked up, you know, I mean, I did a bit of research and tried to figure out, okay, what are other people saying about this? Because sometimes they say clever things. And what I noticed is that in terms of memory leak, the definitions were kind of like wild and all over the place. And really, I just want this really simple definition. Memory leak, chronic condition in which the application allocates memory that is no longer used by the application and is never going to be freed so that it can't be reused by the application. And as I mentioned, this is a chronic condition. So the effects accumulate over time until you get a catastrophic failure. So what are we talking about here? Well, okay, so if you look at the JVM as it's laid out in RAM, you're going to see we have some text areas, some data areas, stack space, and system area. And you know, each of these plays a role in the executable running in your computer. Like the text area is basically all of your libraries that have been statically linked into your executable. And of course, the stack space is, you know, used by threads in order to, well, these are stack-based machines, so they're using stacks in the way you would expect them to be used. And in the middle, we got this data area and shared memory area that's carved out of it. And really, there's some space here for some static things, and then there's C heap. And, you know, C heap is going to grow in this direction, stack space is going to grow down in that direction. So as we have more things, more threads happening, then we have more stack frames being formed, and they'll be allocated in that direction. And this is known as, you know, we call this unmanaged memory. Now, unmanaged memory is a term that comes to us after we have the term called managed memory, because, you know, we had this thing identified with managed memory, and then, okay, so everything else outside of that would then become unmanaged memory. And this can leak. And we get these native leaks in the JVM from time to time. And so we're not really going to talk about that today. That's a subject for another discussion. But we are going to talk about Java heap. And Java heap is a data structure that's going to be allocated out of C heap. And of course, you know, when we use the -xmx or the -mx settings, then of course what that does is that it specifies that Java heap is going to be at most this big. So we're going to reserve space, you know, a contiguous chunk of RAM saying this is for Java heap. And then the JVM is going to allocate out of that space in order to create the place where you're going to allocate your data. Right, so this is known as a managed memory space because the Java virtual machine, the hotspot engine, the allocators, garbage collection, all of these things are going to work together to manage this memory. In other words, allocations and recovery of this memory. And of course, this can leak. Now, it tends to leak in a different way than the leaks we get in unmanaged memory. And we'll look at that in a minute, right? And so this is really a place where we're going to focus our efforts today. So with managed memory, as I mentioned, we have this mechanism in the runtime that's going to basically allocate using these things known as allocators, and use the garbage collection or garbage collectors in order to reclaim memory that's no longer in use. So the Java virtual machine, as you can see, makes use of native memory, and it makes use of managed memory, and it does a pseudo managed memory for internal JNI code. And again, that's a topic for the next webinar in this series, where I'll talk about native memory and how that's managed and how you can diagnose problems in there. So in Java, we really should monitor both types of memory, but we have to recognize that we're going to use operating system tools to look at what's going on in the JNI layer, and we're going to use Java tools to look at what's happening in Java heap. Unmanaged leaks are commonly referred to as native memory leaks, and that's the allocator is going to fail to free memory. And so sometimes it just forgets, so you get a pointer overwrite, and sometimes you just get a pointer problem. And so at the end of the day, you just lose track of where you've allocated. So when you go to release it, you can't, because you don't know where it is anymore. The symptoms is the JVM process is going to grow over time. And when all of RAM is consumed, the operating system is going to start swapping this process as it normally would. And as soon as that happens, you're going to notice a huge decrease in performance. Typically, these are in the order of 5x performance drops. And then when all of the swap space is consumed, what's going to happen is that the operating system will just terminate the application, right? Now, what we see is where people get confused here is that they believe that the Java heap is responsible for this, but do know Java heap cannot grow larger than the max heap setting, right? So once the Java heap is full, it's not going to get any bigger, right? And so managed leaks, this is what people very loosely call memory leaks in Java. And so again, the garbage collector is unable to free or recover memory that's no longer going to be accessed. So this is a bug in the application. It's a semantic bug. So we have data in memory that's no longer semantically useful to the application. It's never going to be accessed again, but we're still maintaining references to it, and that's not allowing the garbage collector to collect this data or return the memory for it to be used again. So the occupancy of Java heap is going to grow over time. GC frequency, pause times are going to grow, and so the garbage collection is just going to run more frequently, and it's going to take longer. And when all the Java heap is consumed, then the JVM is going to terminate with an out-of-memory error. So how this actually works is that the allocating thread is going to fail with an out-of-memory error. But if you have a queue of allocation requests, then all of your threads are going to fail with the out-of-memory error, which is going to degenerate into a general, you've run out of memory and we're going to exit the JVM because we no longer have any live threads running inside the JVM. So common funny things that we see people do is we'll say running the garbage collector several times will free memory. Obviously this can't work. You might run it once and get a decrease. That's just like the garbage that it would normally collect. And you might run it a second time and you'll see another decrease in memory. But generally, by the time you run it the third time, you're not going to see anything more. The second decrease in memory comes from probably reclaiming memory used by alternate reference types, sort of like phantom, soft, weak, and final. Right. So failure to free memory is not the fault of the garbage collector, right? So they'll blame the garbage collector, but it's not the garbage collector's fault. It's a bug in your application. You're not releasing a pointer to data. Larger heap may solve the problem for you. This is one of those cases where you might say, okay, well, I'm just going to make the heap larger. It's going to survive a day. At the end of the day, I can recycle a JVM and basically we're done. So we don't have to do anything. And if that's okay for you, then, that's a solution that some people just live with and they're happy with it. Right. Let's get into monitoring Java Heap here. So when we're monitoring Java Heap, we want to answer two fundamental questions. Is the heap stable over the lifespan of a business cycle? So what I mean by business cycle is like, you're going to have the start of activity, stuff is going to happen, and then sometime in the future, basically that cycle ends and things will ramp down. Generally, it's a day. Sometimes it's a week. Sometimes I've seen it like 9 days. I've seen it 4 hours. It really depends on your domain, what your business cycle looks like. All I know is that by the time I get to the end of a business cycle, I want to see heap return to the levels that it was at prior, just at the start of the business cycle. Okay. And so we're going to ask the question, is the heap large enough to cope with the live data set size and the allocation rates? Those are going to be the two key metrics that you're going to look for, right? So the live data set size is the volume of live data that's consistently in heap. And our working space size is going to be their total heap size minus the live data set size. It's not quite true, but it's close enough that we can just look at it that way. And so now GC frequency is going to be a function of the working space size and the allocation rate. So now you can see how all of these things are tied together, okay? All right, so allocation rate is going to fill up our working space. That's going to determine GC frequency. When the GC runs, it needs to do work with the live data set size as well as the non-live, the dead data. And so, that's going to be obviously your pause time. That's going to affect your pause time. So memory leaks inflate GC overheads over time because, as you can see by the chart here, they're going to increase the live data set size, decrease the working space size, which means they're going to increase GC frequency, which means that we're just going to have more and more GC overhead over time until we hit some magic numbers, after which things will start failing. Right. So we really want to focus on this question here. Is heap stable over the time span of a business cycle? So how are we going to do this? Well, in this case, we're going to use some tools to monitor what's happening in Java Heap. So the first obvious one is JVM that maintains a bunch of performance counters inside the JVM. It's part of the serviceability technologies that are found in the JVM. This is also known as perf data. And perf data is this place, it's a shared memory place, or it's a file that data gets written out to at specific points in time. And you can use this API to basically access all of this counter data. So there's a number of command line tools like jcommand, jmap, jstat, and we'll look at some of those as we go through the exercises. These are exposed via Java management extensions, JMX, so JConsole, Visual VM, Mission Control, and the list of tools that use JMX goes on and on and on. So there's plenty of them. My preferred weapon is GC logging, and that's just because GC logging provides a level of detail that you just do not see in the performance counters. And since this is such a critical key part of your latency picture or the performance of your application, then to me it makes sense to collect this data because it's really cheap to collect, and it's you can do a really deep analysis, thorough analysis on it, and solve a lot of problems really quickly just by looking at what the garbage collector is telling you in the GC logs, right? So so the tool that I use for all of this is known as Sensum, and I don't want to get into the commercial aspects of all of that. We can do that offline later if you're interested. But just to go forward here, what I'm looking at is heap occupancy after the collection. And really what I'm interested here is just drawing a straight line across the bottom of the heap, because I really want to answer this question. Is the heap stable, right? In other words, do I have a flat line that's going to represent the working set size? So in this case, our working set size is a little more than 300 megabytes, right? And our heap size is at around 2.2 gigabytes. Okay, so yeah, and the answer here is yes, obviously, right? It's flat, slope is 0, so we're good. Is the heap large enough? Well, I need to do a little bit more analysis on it, but you know, my guess is that yeah, the heap is large enough here. So probably yes, but you know, we'd take a deeper look at it. Again, we won't do that here. Okay, let's take a look at this example here. And so we're going to ask the same question: is the heap stable? There's my straight line, but that's the line that actually follows the live set size. Yeah, and that's telling me that the heap is not stable, and we're losing about a gig of heap per day. So that's the rate at which we're leaking. And not only that, take a look over there. Do you see what that messy stuff is? Right? So all of this messy stuff over here is just the garbage collector going crazy because, you know, we have this memory leak, it's consuming memory, and eventually you get to this point where it's working really hard for you. It's trying to do its job, but you're not letting it. Cool. Quick word on benchmarking. And I mean, again, this is a whole subject onto itself. You could do multiple days on this alone. But, you know, the common thing we see is, you know, we have problem in production. We can't find it in our test environment. And, you know, why is that? And the reason is because, you know, our performance regressions are very often extremely sensitive to the environments that they're running in. And because our tests generally don't look like our production environments, and there's, you know, no matter how hard you try, you know, you can get close, but, you know, they're just not going to be the same. And because of that, you know, you're just never going to find this performance regression. Memory leaks are a bit different in that they can be seen in the test environments, but you need to run the right use cases, and you need to worry about versions and some other environmental factors. But generally speaking, you know, I could take a memory leak from a production environment and run it on whatever. As long as I get these things right, it's going to show up, and then, you know, I can work to solve that particular problem. Now, we're going to be using some tools, and the tools that we're going to be using require that the JVM actually have spare memory to function, right? And if you've got a memory leak, obviously, you're running out of memory, right? So now you have a problem where the tools are going to be a little tricky to use. So what we tend to do is we tend to back off on the rate. We try to figure out how fast it's leaking and see what we can do to back off on the rate so that, you know, we give the tools a chance to work. And, you know, if we do a static analysis, then these tools need memory, and the current set of tools just have trouble scaling up to analyze larger heaps. I've left queries running on large heaps for like 24 hours before I'd finally get an answer from them, right? So analysis of large heaps can also cause tools to fail. I did start a project. I have to say I've been remiss in terms of making good progress on it to try to come up with a more scalable way of dealing with large heaps and doing analysis in large heaps. Anyways, the downside is there's loads of tooling grief in this space, which you're going to be witnessing today, unfortunately. Okay, because as you try to use the tools, there's on occasions where they're going to fail, and you're just going to have to restart everything and do it again. And cross your fingers, slow things down. You know, just you know, whenever you use the tools, just go light on them and take load off of things before you do things, and just, you know, try to give yourself a better chance of helping the tool get the information that you need. Right. So this is a void, I guess. You know. And I think the commercial tools actually do a little better job here than the open source tools in terms of being able to do this in a fairly stable way. Right. So, excuse me. Let's take a look at just what I mean by benchmarking here. Hopefully this will all work. So I need to just start up this, unfortunately. Yes, I did have this working beforehand, and it's not going to show. Anyways, what I can do while we're waiting for that is I'll just do this. And I'll bring a new window over here. And I'm just gonna, workshops. Okay, so let's just go down in here. And hopefully this will work. Okay, so I'm just going to actually, sorry, I'm just going to do something here. For this one, the story behind this whole thing is that you do need to get some of the version things right in terms of, like, here's an interesting scenario where let's just say that you have this problem in production. So I'm going to run this like under production environment. So this is Nolar JVM, but this is a well-known bug in here. So let's see if this will work. Hopefully. Right. Excellent. So you can see basically success, everything cool. My application runs really, really nicely in production, which it shouldn't. Actually, it should be failing. Okay. Wonderful. Let's see if I can just do it in here. Okay. I'm going to abort this demo because something has happened here that I'm not sure exactly, and I don't want to take the time to look through it, but I'll go through it later. But the essence of the demo was supposed to show you that in 17004, what happens is that when you did substring on a string, what it would do is say, you know what, I'm not going to go through all the expensive work of copying the string. I'm just going to put pointers into the underlying buffer. And so what happens is that in this particular benchmark, what happens is that we just do a bunch of substrings and we fill up things, and eventually, like this version here is supposed to run out of memory. And in this particular version, and I'm not sure why it's not, I'll have to take a look. It did when I tested it yesterday.
Kirk, I think it's still using the old JDK 170. If you look at the path there, it says library Java virtual machines 170 JDK.
Yeah, it's fine. It's
probably using the old JDK for that. Yeah, but if you look at the top, you see there's Kirk upgradable. Underneath that, there's library Java virtual machine 170 JDK.
Yeah, it should be 170_04. That's the one it should be using, because that's the one that has the thing, okay, the thing where it basically takes the strings and just keeps the original string, which we throw away in this case. So we create these really large strings, we just take a chunk out of them. And then what happens is in the end is we just run out of memory. And if you go to 170, something bigger than this, what they recognize is that people were running out of memory because of this thing. So they optimize the code not to do the string copies and keep all of these extra strings in memory, but it ran applications out of memory. If you go forward, what they did was they said, okay, we're just going to copy the string in that particular implementation. And when we actually get to that particular implementation, then what we see is that you don't run out of memory, and that the application runs to success. Now, and this only shows up for 170_0, you know, the first release until the 05 release. And we've seen things like this happen. Like, people will make optimization decisions which will have detrimental impacts on in production environments, and so they'll roll back or they'll do something different. And which means that if you go and have something in production and you use a different version in test, right? Just a different version of the JVM, even though it's like 170, still 170, you can still run into these particular problems. So in terms of benchmarking, you just want to be really careful. Really, really careful that you make sure that everything is the same as much as possible in terms of the versions of the software packages and things that you're using to build the product. Okay, that's pretty much all I want to say there. And right now, what I want to do is I just want to go over and I just want to open up this other little application, which hopefully we'll have a little better luck with. Okay, open. And
this problem that Cook is talking about has been with us from Java 1.0 actually up until now.
Right. Okay. So here we go. So here we have this application
Just
here.
a quick question whilst you're there. Could you set your monitor to 720p by any chance?
Yeah, sure. If we're having trouble.
Yeah, it's just hard to see on
a small device. Yeah, I can imagine.
Yeah.
Okay. So display.
So scale to make it 720p.
Yeah. So
whatever
it's not actually showing the Retina display. Let's gather the windows here. So I can see the Samsung monitor that I'm attached to. You know what I could do? Here's what I'm going to do. What I'll do is, if you want to just get it over, I'm going to just flip things around here a bit. And I'll automatically go to 720 when I flip everything over. Okay, and okay, so let's go. Can I actually change the screen? I'm going to hide my webcam at the moment. Can I change my screen?
Just use the scaled option, Cook. Just use scaled option to make 720p.
Yeah, I would love to.
Open display preferences.
Arrangement, color, night shift, display.
Click on scaled. Scaled. No, display, scaled.
Oh, scaled. Yes, okay. Okay. That's 1020. No, it looks like all I can go down to is 1024 by 640. Or 1280 by 800.
Doesn't matter, just make it bigger. Just make it bigger. That's fine. 1280 by 800 is good.
1280 by 800. Okay.
Yeah.
Is that better?
It will be. Yeah, that's better.
Awesome. Okay. So let's get back to what we're looking at here. So I'm running this application here, and you can see it's actually monitoring heap occupancy on its own here. So you can get an idea that this bottom line here. So there's about 20,000 K, or maybe less than that. Yeah, so the working set size is somewhere, 10, it doesn't matter, it's low, okay? And so we're gonna do stuff here. And you can see as we do stuff, we're just going to start losing memory. So, in terms of monitoring leaking and stuff like that, if we look at the so this is an event polling based mechanism where I'm using the JMX bean in order to basically get the value of the current occupancy of heap, which is very different than if I actually were to use, let's see if I have a terminal here. Make this big, smaller, bring it up. And let's see, do we have it? Oh, yeah, okay, so unfortunately I don't, but we can fix that pretty quickly. So let's try editing configurations. So really what I want to do to monitor this thing is, and I'm going to, okay, and there's a bunch of other flags I can set here, but I'm probably just going to leave it at, sorry, during okay. So we can hit the apply, hit the OK, and I can shut this down and basically run it again. Oops. Typo.
Distribution.
Yeah, I always do that. My fingers are just, my left hand types faster than my right hand sometimes. And why is it not? Okay, well, we don't really need it for this thing, so I'm just going to take it out rather than fight with it. Okay, so anyways, so the point is, okay, so we have the application running here. So if I go back to our terminal window, you can see we now have a GC log. And you can see it's running a parallel collector and everything like that. So we get some data. So as we do stuff and do stuff and do more stuff and do more stuff and do more stuff, what we can actually do here is, you know, take a look at it again. You can see that, so basically, you know, the garbage collector is running and we can get a lot of data here. Very difficult to look at in this sense. So what I probably am going to do is just bring up some sort of way of viewing it. Well, as you can see, we do a lot of GC log analysis there. So, and right. So I can bring this up and you can see that, yeah, even after the full GC, we have this line basically going like this. So what's happening is that you can see that the effectively we're losing heap over time, right? And there's other ways that we can actually look at this if we want to. So we could use, for instance, jcommand. So that's a command line tool built into the JDK if you haven't run into it before. It's pretty much self-describing. So you can see that when I just hit -H, it's going to start giving me help. So, you know, what do I want to do? Well, what I want to do is I want to find out which JVMs are running and which ones I want to connect to. So I'm just going to do this jcommand -L. That's going to go and list all of the Java virtual machines that I have that I'm able to access. Obviously, I'm interested in this one. That's the PID. So if I can do a jcommand and that, and I think if I type in help here, it's going to list all of the things I'm able to do against this particular Java virtual machine. And you can see that basically there's a number of things I can do in terms of monitoring what's going on here. So I can get more help about what's happening with memory. I can actually do a heap dump if I need to. I can get a class histogram. So let's see what that actually looks like in this particular case. So setting jcommand. Oops. Sorry, what was the PID? I didn't remember.
So just to understand what you're doing now, you basically want to confirm or deny that there's a memory leak. Is that what you're trying to do? And you're showing different tools to do
I'm basically just confirming or denying that there's a memory leak and just showing you exactly what's going on in terms of the memory leak and stuff like that, and showing some of the tools that you can actually use to look at what's going on here. Now, jcommand isn't actually really all that useful for confirming or denying a memory leak. I mean, you'd have to run it several times to actually get the information out of the JVM. So some of the tools, like, well, you know, let's look at the useful tools then in this case, right? So if I look at
for the purpose of confirming the memory leak, would it be enough to connect with Visual VM and look at the memory usage and click perform GC a few times?
What I've done right now. So I've just started Visual VM up.
Okay.
So here's Visual VM. Unfortunately, my toolbar is in the wrong place. So basically, you have to open the applications view here, and you can see again these are all the JVMs that I can attach to. So oops, hate when that happens. these are all the JVMs that we can attach to. And again, it's using the same type of mechanism as JCommand to get the information. The only thing is that this is obviously a huge GUI written on the NetBeans platform. So it's got a lot of functionality into it. So we can look at here monitoring memory. And if I go back to the application, I can actually do stuff again. And we might not see it actually. And I can do stuff again. And you can see what's happening is that we're getting a slow leak here, but effectively that the heap is actually rising over time. And even if we do a full GC here, we're not really getting.
Can you show us where exactly we can see the heap rising?
Yeah, right here. This blue bit here.
Right.
Okay.
So the blue part, the blue graph going up, that's the heap rising.
Sorry?
The blue graph is the heap rising, and the
blue graph is
orange
the heap rising. The red one is actually the total size of heap.
Right.
Cool. Right. Okay. Let's shut all this stuff down and go back to our slides.
And in this case, performing GC didn't do much, so that's sort of a good clue that you've got a memory leak.
That's a perfect clue that you have a memory leak. When you do the garbage collection full GC, you're going to notice that you get no recovery. And this gets important when you start using G1 because unfortunately with the G1, there's only certain memory spaces that will be collected when a full GC is called for. And because of that, because of that, you can get confused sometimes. You can look at it and say, do we have a memory leak here? Well, we'll run the full GC and we'll get a good recovery, and then we know that okay, there's something else that's going on here.
A question by Alexi. Can you connect to your production server with Visual VM?
Yes, you can. It can get a little tricky. This is why we tend to basically prefer some of the command line tools like JCommand for doing that, because you can just run JCommand over time. Sorry, I didn't finish that demo, but we'll look at it again. So basically, you can just monitor it over time. The thing is with getting it to connect to production is that generally the way I'm going to do it is I'm going to run Visual VM in production and tunnel it back, but that's only when I'm doing diagnostic work. So what we do ourselves for our customers is we actually just collect the GC log and we do all the analysis off the GC log. To me, if we have that data, we can understand if there's a leak, and not only that, if there's anything else going on and there isn't a leak, then we can do basically a deep analysis as to what's going on inside that JVM, and then prescribe some changes that might help the situation. Okay. Other than that, there are monitoring tools you can get that will just give you like maximum heap size, and they'll do that using the same mechanisms that Visual VM will use, but they'll do it in a slightly lighter way in terms of they'll set up a better communication channel from the host back to the thing that you have monitoring.
Also, what you said at the beginning, Kirk, is that you can actually reproduce this type of problem quite easily with benchmarking, or at least in a test environment in comparison to other types of performance problems.
That's correct. And so once we've identified the heap is unstable, then I'm going to want to move that to a test environment and do the rest of the work there. Most of the other performance stuff that I look at, we're going to want to do it directly in the production environment, which I know sounds controversial, but That's just the way we've been rolling for, I don't know, quite some time now, many years now. That's pretty much where we've been doing all our diagnostic work. Cool.
Just a note, those of you who have joined recently, if you have any questions, please type them in to the question panel, and I will interrupt Kirk at an appropriate time and ask him.
Yeah. Cool. Okay, so going forward, now that we've identified that heap is unstable, the question is, now what do we do? Well, as I was about to show you, we can use J-command to get like a class histogram, and that's going to ask the garbage collector to produce basically it's going to walk all of the references for all the live objects, and it's going to give data back to the tooling, and it's going to build this histogram of, what's live, how many bytes of what is in heap. And we can look at the histogram, and generally the good candidates for leaks are going to be, those things that are consuming most of heap. Yeah, it's going to show you the most prominent object in heap. No, quite often these are byte arrays or car arrays or arrays of string or something, or arrays of object. But so the usefulness of the tooling is a bit limited. I mean, it's going to tell you what's leaking, but there's a lot of other information that we can gather using other tools that's going to make it like really easy to figure out what exactly is going on, right? We can also use JMap to get the same histogram. And as you can see, going forward, we can use these things to get heap dumps also. So let's just walk through, what actually happens in heap here. So here's a chunk of code, and I'm going to give you what generally happens. And there's, the JVM is a very complicated piece of software, and it does a lot of things. So it could mangle this code and do some very interesting things with it. So I don't want to talk about that. I just want to talk about the straight line case. That as what you'd expect to happen here. Okay, so we have allocations in Java heap. So we got, here's a chunk of code, and you can see there's 4 different variables in here. And here's my heap space, and I got it color coded so you can do some word, figure out where the words are fairly easily. And we have this other space, which is like perm space, meta space. So I'm not going to really talk about them too much today, but as you can see, perm space and meta space together point into Java heap. Here there's nothing to point at the moment, but generally what happens is that when your classes, your application gets loaded, a lot of that data gets placed into these locations, and then we have to have these definitions around for the runtime, and so therefore we have these pointers back and forth, which we'll look at in a second. Okay, so these 3 lines here form what are known as allocation sites. And so as we go to execute this code, what we're going to see is that we're going to look at these allocation sites in the code, and basically what I want to do is I want to create some space on the stack for them. And so I'm going to allocate a stack frame, and I'm going to start to build up the stack here. So when I do the int ID equals 17, then essentially what's going to happen is that the 17 is going to be allocated directly into that stack space. When I get to this particular thing where I have a string, so this is a real allocation site, this is going to do a heap allocation. So the first thing that's going to happen is that we're going to allocate the string. So what does this look like? Here we have a byte array, so that's a reference to a primitive array of bytes, and we have an int hash code value. Okay, so that's a primitive value of type int, and down here we have a static field, which is a serial version UID. So for whatever that's used for, it's in here, and we have this other thing here, which is a static reference to an array of object stream field. So the things that we really are concerned about are an object header, the int, and the reference for the byte array. Those are the things that we're interested in, right? The static fields are actually going to be attached to the class and the class loader that's loaded that class. So they're not going to be part of the allocation of this particular object. Okay, so if we go back to memory and look at it, you can see that, okay, in the stack, I'm going to have a reference to the object header, and the object header is going to have some reference into metaspace, and metaspace will have some reference back, but you know, it's just the way it works. And you can see there's int, then I have a gray area, then a ref, and then an int, and then a byte array, right? So the reference is to the byte array, and so we have the object header int ref, that's one thing, and then we have the int byte array, which is the second thing. So these are going to be allocated in one contiguous chunk here. And I have this gray bit in there, which is padding. And what the padding is going to do is it's going to make sure that things are word aligned. So the things that need to be word aligned are going to be word aligned. And so generally references need to be aligned. Now, this is not using compressed oops, as again, there's other conditions that complicate this picture. So I just want to look at the simple one. But anyways, and the point here is just, you can see just basically how much memory this thing is actually taking in order to get this email address into, to reference this email address in your application. So when we go to name, Fred, we get the same thing, right? And by the time we get down to executing this thing here, which is a contact, right, which is a different object, so I got this constructor I'm calling, you can see I have the object header, an int, padded, and a ref, and you can see the references are pointing back to each of the other the data here. So basically what happens is that when you get this really messy view of it's a very complicated thing. So you get this graph of pointers flying all over the place, right? So if we simplify the view here, you can see that basically we have a number of pointers to different things, and they're color coded here. So we have purple, and I got red, and I got blue. So there's specific color codes for these particular things. So when we go to clean heap and we get to this garbage collection cycle, the first thing we need to do is we need to do the scan for roots. So let's find all of the GC root objects. So a GC root is any object that is live by definition. So if I want to collect the area in purple, okay, and I'm going to look at these pointers, I'm going to try to figure out, okay, which one of these things actually comes from GC roots and which ones are not. So we have some definitions for these. So we have these things known as internal pointers. So this is a pointer with a property where the refer and the referent are both inside the memory pool that's going to be collected here. So the blue pointers are internal pointers. And so these are going, so these are going to be not part of our GC root set, right? Because our GC root set is going to be external pointers. And that's pointer with the property where the refer is outside of the memory pool and the referent is inside the memory pool. So as we can see, we have the stack frame, and we have 3 pointers there, and we have metaspace, so we have a pointer there. That's going to be pointing inside to something inside here. So when I do the scan for roots, one of the places I have to go to is where the stacks are, and I have to scan them to see, okay, what's pointing into my memory pool. And the other place I have to go to is metaspace. And there's a whole bunch of different other places we have to go to, but we'll just focus on these 2 for now, right? So basically, we're just going to say 1, 2, 3, and 4. That's going to be our root set. And now we're going to start what's known as a mark and sweep. So with a mark, we're basically going to trace the pointers, and we're going to find all of the live pointers, and we're going to mark that data as live. Anything that's not marked as live, when we sweep it, we're going to reclaim that memory and put it, and we're going to make it reusable to the application. Okay? So this is a high-level mark and sweep. In OpenJDK, we use a couple of different techniques in the sweep. So I don't really want to get into them right here, but you just know that, this is a fairly complicated process, and there's a couple of different options in play here. Okay. The net effect is all the memory that's not referenced will be returned to the JVM, to return to Java heap, so that your application can now do new, and it's not going to fail. Okay. So if we look at managed systems and we revisit, we're saying in managed system, memory is considered to be leaking when the reclaim mechanism is unable to free memory or data that will no longer be accessed. The data is still live, cannot be recovered. There's going to be a bug in our application code, and most likely a bug in our application code. But with tracing collectors, this absolutely will be a bug in our application code, because as you can see, GC's tracing collectors are precise. They know exactly what is live all the time. So that means we got a bug in our application, and that means we have unused data that's unreferenced indirectly or directly from a GC root. So you can think of it this way: we got a bunch of data in heap, a bunch of it is referenced, a bunch of it isn't referenced, right? And so the bunch of it is also unused. And so the bits that are unused that are still referenced is going to be the thing that's leaking. And generally that area of that leak is just going to get larger and larger over time. And that's what's going to cause the problem. So our task, find the data being referenced but is no longer needed. Cool. Now, the funny thing is, and this is where I got into the the half-hour, 4-hour discussion as in terms of how long. There's a whole bunch of typical causes, the things that happen that we find are responsible for memory leaks in our application, and here's a list of them. But I always reduce it to this: there exists at least one pointer chain from a GC root to the target object, or the object that is leaking, right? So all of these different cases or causes generally, they're all going to be reduced to this one point. We have a GC root, we have the object that's leaking, and our application is not making taking the step to dereference that data that's leaking, so it's collecting it someplace. Okay. So let's take a look at this way. More definitions. Object age. Number of collections that an object has survived. A generation is objects of the same class that have the same age. So if I create a bunch of strings, and these strings have all survived one garbage collection, then that would be one generation, that would constitute one generation of string. Generational count is the number of different generations for a class, right? So that one generation would just add to the generational count by one. So if I'd have to look at all of the different generations and sum up how many different generations there are, and that would give me the generational count. Okay. Now, these definitions aren't just for fun. They actually help us compose a diagnostic process. Okay, and so let me show you this. So here's a bunch of objects, all at different ages. Okay, and we go up to age 4 in this case, just because, Anyways, so the point is, let's figure out in here what's leaking and what's not. So we're going to use the generational count to do that. So while I'm going through this, I'll give you a little second here. So just, I'll put the shape up and then I'll ask you, and then I'll show you what it is. So if you look at a circle, just try to see if you can calculate its generational count with the data that you have here. Don't worry if you get it wrong. Just give yourself a chance here to look at it. Okay, so it's 1 because it's all of these circles are of age 1, and there's no circles of age 2, 3, or 4. So it's in one generation, so the generational count is 1. Now if we contrast that to the cross, I think you should see by now this is just going to be 2 because it's in age 1 and age 2, not in age 3, not in age 4.
Kirk, if I can stop you for a second.
Sure.
Can we just rewind that a bit? And in fact, before we do this, can we take a short break? And then just go over this again, because what we really want to do is get people to vote, to sort of say what they think. But I think we need just a short break. Can we maybe give us just a 7-minute break? Body
Yeah,
break, and
sure.
then we'll continue.
Let me set up a 7-minute break. Heinz, thanks for stopping. I was looking at the time, wondering if I should just finish this and go with the break, or go with the break. But I'll go with the break.
This is one of the most important slides of the entire course. So I'd prefer people to take a short break and then come back to this.
Okay. So I'm going to start a 7-minute timer here.
Yeah.
And when the timer goes off, then I'm going to start again. Okay?
Perfect.
And there it is. Were there any questions in the meanwhile, or should we just answer them after the break?
I've been sort of typing in answers to some of the questions that we could do with like that. There's one about Java, but you're going to do a demo of that in a moment anyway. So
yeah, sure. Okay.
And we'll use it. So let's just take a break and then we'll come back in a moment.
Okay, 6.5 minutes. Make it quick.
Massimo will answer that question when we come back from the break.
I'm game with that. Okay. Okay, that's funny.
You don't take a break, Kirk? Walk around a bit?
No, I want to figure out why my demo failed, and I actually just figured out. So now I'm trying to figure out how to fix it.
Okay.
Why? Do you think I need a break?
Yeah.
Yeah.
I think so.
I'm really upset that this thing actually failed, and now I see why.
It wasn't such a great demo anyway. It's okay.
Disappeared. The source code has disappeared. The package is there. There's no source code in the package.
I'm going to mute you now.
Hmm?
I'm going to mute you until you finished. All right, Kirk, let's get back to that screen that you had of the definitions. I'm going to lob some questions at you from my group here, and let's get you unmuted again so we can hear you. There we go.
Thank you.
All right, so
I have no idea what you're doing
Massimo
there.
Calderoni would like to know the difference between object age and generational count.
Age? Oh, good. That's a really good question. So the age applies to just to an individual, just like you, right? We go around the Earth, around the sun once. Your age gets ticked up by 1. You know, in this case, it's not time-based; it's more garbage collection cycle-based. So if a particular string survives a garbage collection, then its age gets ticked up by 1.
Okay, before you go on, before you answer the generational count part, Ronak also asked, is it defined as a number of collections objects survived? Is it any collection, young or old?
Any collection. Doesn't matter.
Okay. Okay, and what's the definition of generational count? What's the difference between that and object age?
Well, object age is an individual thing. Generational is, well, it's a population thing, right? So, I mean, you can think of it your family, right? How many different generations are in your family? And again, that's a time-based thing. You know, if you might have your grandparents and you might have your kids, which means, and your parents in there. So that would be, the family would be 4 generations, which would be really kind of cool, right? You know, so as you can imagine, some families may have more generations based on that. But you know, so in this case, it's data like you know, if I look at string, I'm going to ask the question like, okay, how many different generations do I have? In other words, how many individuals are of different ages? Right. This is why I go into the example, because I think the definitions are useful, but when you get into actually the visualization of them, then what happens is that you can look back and say, oh, okay, the definitions make sense now.
Yeah, absolutely. So let's look at that.
Yeah, exactly. So that's why I want to go into this. That's why I definitely want to go forward into this. And here you can see that I have individuals, so I can look at, actually all of these questions will come out during the demonstration. If they don't, I can explain them again, okay? So again, we did the circle already, and I said, okay, that's of age 1, because it's only, all of the individuals are all the same age, and they comprise 1 generation, right, of age 1. And the generational count is also 1, which might be confusing in this case, but you can see that if I go to age 2, age 3, age 4, there's no circles. So all the circles here are of the same age. So there's only 1 generation of circles. Okay? And I did the cross also beforehand. And again, the same thing here, right? If I look at it, there's individuals of age 1, there's individuals of age 2, and I have in here, you know, so I have 1 generation for the age 1, another generation for the age 2. So now I have 2 generations of crosses. So the generational count is 2. Okay? So the next one I'm going to look at is a half ellipse. So I'm going to ask, what is the generational count? Well, we can ask, yeah, what is the generational count of the half ellipse? Okay. And just thinking, so just try to do this calculation in your head on your own right now. It doesn't matter what, you know, what answer you come up with. Just try to go through the process. I'll give you a few more seconds.
Some answers coming through. 1 by Panayoti. Very good, Panayoti.
Right. So the answer is there's only 1, because it's only in 1 generation, but the age is 4. okay? And and the age is 4 because it's survived, you know, so we've created one and then we just keep a reference to it and it just keeps surviving garbage collections. So it just keeps getting older. Yeah? But in terms of generational count, it's only 1 because it's not in 1, 2, or 3. And we can go through the rest of them, like the triangle. Again, it's 1. The next one I'll look at is the cloud. You should be able to see that it's 2. And really what I'm trying to do is I'm trying to draw something that represents what you typically see in heap. And the difference comes in is if we look at the star, you can find the star in all generations and its generational count is 4. And so when I add this is what a heap typically looks like when you have a memory leak in it. So up until, if you take the stars out, that's what a heap would look like normally. You put the star in, and you're going to see that this is what a heap would look like with the when you have a memory leak. You know, so why is this leaking? And the answer is that well, I have stars in every single generation, which means that I keep creating them, and I keep retaining references to them. And if I keep doing this over a long period of time, eventually I'm going to run the JVM out of memory. Okay, so that's why this is a leak.
Is there a limit on the maximum number of generations?
Well, okay, theoretically, no. In practice, of course, you're going to run out of memory. Or time.
if you look at it from another perspective, how do you find the object with the oldest age? In other words, your cached memory.
Oh, yeah, we'll get into tooling in a minute. Okay.
Okay.
So there's only one other question that to me is, I mean, sorry, there's one other question that people typically ask, and that's why do I think the hash, the half ellipse or the ellipse is cached, right? Maybe we glossed over that. You see, like, you know, so like circle, cross, triangle, cloud all have normal life cycles, but the half ellipse is either cached or leak. You know, I'm going to say it's possibly a leak too, but this is generally what cached objects look like, or one pattern of cached objects. And the star of the leak, I think that's fairly obvious. So that really gets us into talking about object life cycles. So normal churn, data tends to live for a very short period of time, on the order of handfuls of machine code instructions, which means that data is often not referenceable or not accessible before it actually leaves the CPU, actually even before it leaves the store buffers inside the CPU. So that means that most of the data doesn't survive a single garbage collection cycle. Now, caching patterns, as we all know, caching is a really cool technology. We use it everywhere. It's very helpful for performance. But it does do something to garbage collectors that garbage collectors tend not to like. In other words, it leaves data in memory a long time, which means that they have to keep dealing with it over and over and over and over and over again. So you'll accumulate cost over time. So we want to use cache where it's going to make a difference, but we just don't want to use cache everywhere because that's going to increase the cost of your garbage collection. But anyways, different topic. So the caching patterns are generally, we create a static cache. So that means that, you know, we start up our application, we create this big array, and we stuff a whole bunch of stuff into it, and it stays there. And it only goes away when the process exits. Okay. So data will be old. In other words, it's the age of the individuals in the cache will get really, really big, large, but you should not have many generations. The generational count should only be like 1, 2, 3, or like a handful, like 4 or 5, something like that. Very small number. The other caching pattern is that we have a cache and we're going to put data in it. It's going to stay there for a period of time, and either LIFO, FIFO, or whatever. There's some sort of life cycle, and eviction policy where the data is going to get kicked out of the cache. So this sort of looks like normal churn, and really in this particular situation, we should still have very small generational counts. So data is going to flow in and data is going to flow out. And that's normal object churn, right? We create and we throw away. It's just that the life cycle is going to be extended for the amount of time that we're in the cache. But again, the generational counts in here should be fairly stable and they should be fairly small. You shouldn't have very large generational counts in here. When you get to a memory leak, we have unstable generational counts. They're never going to stabilize. And in some cases, the generational count is actually going to match a number of garbage collections that have occurred, right? Right, so memory leak. Old is never being released, new is constantly being created. And this can happen in caches. If you have a bad cache eviction policy, then what happens is data will accumulate in the cache, and that'll be a leak. We've actually had companies selling caches with no eviction policy, and so people kept stuffing data in them, and of course, they had a memory leak. And of course, you go back to them and say, well, it's a cache. It's supposed to have lots of data in it. And my answer to that is that it's still a leak if you don't have a way of controlling the amount of data that's retained in the cache, either by setting it up statically or by having a good eviction policy, right? So point is, generational counts will always be increasing. You're still getting more and more data into heap, and eventually you're going to destabilize the garbage collector, then you're going to destabilize the JVM, and eventually you're just going to exit, right? It's just going to run out of memory, and you're just going to get a termination of the process. Okay, now, but this is cool information, right? Because if we have an unstable generational count, then all we need is a tool to actually tell us what the generational count is, and we profile for that. And we're going to profile then for the allocation sites. We can trigger a heap dump, and we can use the knowledge of what what's leaking with the knowledge of where its allocation site is, with the knowledge we gain from the heap dump, to really come in with a ton of information that's going to help us debug the problem, right? That's just like overkill in terms of the amount of information that you typically need. Right. Fix and then test. So I want to talk to you about the anatomy of a leak then, in this case, right? So if I look at the anatomy of a memory leak, you can see that I have a GC root, and typically I'm going to have some sort of collection here. In this case, I'm going to have a map that has a map entry, and a map entry is going to have a key, and it's going to have a value. In this case, I'm going to say the values are leaking object, and the object is going to have some structure, so it's going to have some fields of its own. And so these are going to be like leaking fields that are going to be attached to this particular object. Now, this is all going to travel as a gang, right? So all of these things are basically going to, like the map entries and the keys and the leaking objects, they're all going to have the same generational counts, or very close. They might be off by one, right? But all of these things are going to leak together as a group. And really, in order to be effective in finding out what's going on, we want to find the allocation site for this thing here, the leaking object. That's where we want to focus. We want to put our focus right there, okay? Because map entries, they're being created and destroyed all over the place, and they're used in other things, right? Generally, what we find is that the leaking object is going to have one allocation site for it, one causal execution path to get there. It might have two or three, but generally it's going to be one. And it just makes the process of finding this thing so much easier. The leaking fields quite often tend to be strings. And strings are just abused and used all over the place. So again, trying to hunt for a string, you can do it, but it's just making your life more difficult. Just try to find the domain object that's involved with the leak and focus your efforts there. That's going to make it very, very easy, okay? And this is why it makes generational counts very powerful, right? Because like we can, if you look at a memory leak, it's a problem in dynamics. It's a dynamic situation that's evolving over time. If we look at just taking a heap dump, what we're doing is we're taking a snapshot. We're just taking one snapshot of something that's happening like now. And you don't get to see the picture over time, right? And with the generational count, we can see the picture over time. And that's what makes this technique very, very powerful. By the time we get to taking the snapshot, then it gets a little trickier. You can still do it, but, okay. And quite often that's the only way we can do it, but we'll just do that. Okay. So if I haven't answered any of your questions, then what I'm going to do is I'm just going to go through this demonstration of basically how we will figure out what is actually leaking inside Leaky. Okay? Any questions there, Heinz, or are we free to go?
No, there were questions, but I've sort of answered them whilst you were talking.
Oh yeah, there's lots of. What is Eclipse considered? What?
Yeah, so
Eclipse considered or oh, I see. Ellipse, I should say. Yeah. Yeah, it's age 4, which means it survived 4 garbage collections. It's in 1 generation, so it's generational. So it's generational. Number of generations is 1, so that means its generational count is going to be 1. I think she was trying to write ellipse and spell checking got her. Yeah, it happens to us all, doesn't it? Okay. Cool. So let's go back to
by money. Kirk.
Sorry? We have something from Mani?
How did the cached object get to generation 4 directly?
Oh, it didn't.
Because
this is just a snapshot in time. Origin. Yeah, at one point it was age 1, then it went to age 2, then it went to age 3, then it went to age 4. And if I extend the example out, it would go to age 5, 6, 7, and so on and so on. Right, don't forget about structures of heap memory and all of this. Don't think about all of that. Just think about we're just allocating into this memory pool, whatever it looks like, we don't really care. That's a garbage memory management question, which is sort of outside of the scope. We need to have some knowledge of it, but I don't want to talk about heap structures and things like that, because then this thing gets to be a very long webinar if we do that. Okay, so and it's not really necessary for memory leaks. Okay, so what I'm going to do now is I'm going to close this down because it's bugging me, and I'm going to go back to Leaky. Eventually I'll get there and you'll be able to see what I'm doing. Okay, so here's Leaky. Let's close this up. And I wonder if I can do that. I'll do it from here. So I'm gonna start Visual VM here. So Visual VM is going to be the tool of choice. Now, I say this because Visual VM is actually the JFluid profiler inside Visual VM. It's the one inside NetBeans. Is the only profiler that gives you a proper generational count. All of the other tools that say they give you generational count actually do what's known as a diff between snapshots in order to try to estimate what a generational count might look like. It's still a fairly effective technique. In other words, you can be very sloppy here and still get reasonable answers. I just use this one because it's more precise. So that means you can get to the answer quicker. You don't have to burn it in as deeply in order to figure out what's going on. Okay, for a number of reasons. Okay, so let me just go back to Leaky here. And so it's running. Yeah, so if we go to applications, we can see Leaky should be here. So let's attach to it. And here is the JFluid profiler. Pull this over here so you can see it a bit. And if I go to memory settings, because I'm going to memory profile here. So what I'm going to do is I'm going to say, okay, let's just profile for everything. When you get a profiler, my recommendation is look to see what the filters are. The most, what I usually say is that the filters are there to filter the bottleneck out of the profile, right? And and that's because that's generally what happens is you'll have a bottleneck someplace in your application, and then the filters will be there trying to make sure that you don't, trying to cut down on the amount of work they're doing, the amount of data they're collecting and presenting to you. So they'll filter things out. And if you don't understand what your filter settings are, and you don't know where the problem is, then of course, you could be in this situation where you're going to miss the primary bottleneck just because the filters are going to filter it out of your result set. Okay, anyways, so here I'm just saying, like, let's look at all classes, let's look at all arrays. So those are the things I'm interested in. And I could preset that here. So anyways, I won't do that, but then we're going to attach our profile. And as we attach our profile, we should see generational counts over here, right? So I'm going to make this one bigger. So there's some of these things I don't really care about. Actually, I don't really care about allocate it in this particular case. What I'm really interested in is the generational count. This is going to form a power curve. See lots and lots and lots and lots of zeros. And it's only when you get to the top of the list that you're actually going to see things happening. Now, unfortunately, in this case, what we're actually going to see is a little bit of leakage because of the way the profiler works. But we can, generally even the profilers can't hide from the profiler. So let's do stuff here. And we're just going to watch the generational count. Okay, let's just bring this over here. Maybe we can see it. And you can see the generational counts are climbing here. And unfortunately, what we're actually witnessing, as you see the beach ball, is that this is the overhead that the profiler is actually putting onto the application. And this is, I guess, the reason why people generally don't like profiling in production. And I completely agree with them. In terms of running generalized profilers to run in production, difficult. We do run profilers in production, but we handcraft them, so they tend to not give you this amount of overhead. Okay, so as you can see, what's happening here is we got a bunch of things at generational count 24, 23, and you see again, it drops off very quickly. And okay, we're beach balling here. So I'm just going to take this off so I can watch it, but I'm going to press as soon as it's not beach balling, then I'll press the do stuff again. Okay, so it's finished beach balling. So I'm going to do stuff again. And we can start looking at what's going on in here. So we're at 32, 31. So this is the area that we want to look at. See if I can make this bigger. And see if there's anything interesting in here. Whoops. And, whoa, okay. So it actually, it's really kind of funny. It looks like we have a number of things leaking in here. So we have some tabular data support. We have some composite data support. So that's some MX beans that are actually a result of the profiling. And then when we actually get down to here, we can see we have some collections here, but our domain classes really end up with these really high generational counts of 27, 28. And so I would say that, yeah, it's really kind of funny. I guess it's going to be a bad demo day.
The first question is from a bunch of people. Actually, can they get hold of that leaky program that you wrote?
Yeah, I'll put it up in GitHub so that people can download it there.
Yeah. Okay. So what we'll do is also we'll put a link up in the course as well with exercises. The second question is Matteo asks, can you get false positives with a high generational count by looking at it that way?
If you go after a domain object, the answer is I would like to say that the answer is no, and I never have come up with a false positive, right? But having said that, there's probably something in my imagination that's failing me that that would allow me to come up with a false positive. Actually, sorry, there is one nice case for false positive. And that's a very complicated topic, but it's not really going to happen all that often. Actually, very difficult to happen, and that has to do with what's known as allocation site elimination or reduction, and that's an optimization that the hotspot engine can apply under certain conditions, and it might be that when you're profiling, you're not going to meet those conditions.
Okay, another question which I'm going to answer is about getting the profiler to work with Visual VM. Now, when you use Visual VM, first of all, best is to download the most recent version from the website that I sent you. Secondly, make sure that you're running it with the same version as the application that you're testing. That normally gives you the best results for best compatibility. So you want at least Java 8, and then make sure it's the same version, exactly the same that you're using both for Visual VM and for your Java process. Kirk, what's your opinion of your kit in terms of generational count?
Your kit, JProfiler, I love them both. I think they're really awesome tools.
But right, in terms of generational count,
they're well worth the money. They're well worth the money. I have no hesitation paying the license fee for both of those tools.
So the question is not, do you like them? The question is the generational count. How does it compare to their generational count?
Oh, their generational count is going to be an estimate taken between snapshots. So it can work, but it's not quite as effective. But the advantage is they tend to have lower overhead. So there's unfortunately it's not an easy answer here, because there's, as you can see, this thing comes with a lot of overhead that you don't get with JProfiler and your kit, right? But their instrumentation isn't quite as good, but it's probably good enough. You see? So you take the overhead hit, you get a very good answer. You reduce the overhead hit, you get an answer that might be good enough. Right? Or you take a heap dump and use that technique. We'll do that later, but and so therefore the overhead hit is very low, but then you have more problems to deal with. So the quality of the data isn't quite as good. So it's always a trade-off. So I wanted to show you the best one first, and then walk backwards through things.
Another question from Stefan Dragnev. It seems to me that you are looking both at the generational count and the number of live objects to determine where the leak is in the demo. Is that correct?
Yeah, and that's just because the timing here, because of everything that I have running, is meaning that I can't, there's enough stuff happening on this machine, and this is a problem with doing performance exercises in this format, that there is an underlying thing happening with the profiler that's actually dominating the picture here, and I know that's something that we normally don't see, and that's just because of the busyness of the machine and the interference and overheads and things like that. And so normally you get a stronger impression. So like you can see what happens right now is that I'm getting XY data chart here, which is an artifact of the JavaFX application running. And that sort of is dominating the picture. And it's making it difficult for us to even see leaking now. So there's enough noise in here that it's a bit of a problem. That we've basically lost it. So I actually have gone to not allocated objects, but number of bytes, live bytes, just to help clarify that. What's going on here? Live bytes, it's big. Oops. Okay, yeah. Here we go. Yeah.
Okay, so a bunch of people ask, wouldn't it be better to use Flight Recorder?
Would it be better to use Flight Recorder? I will talk about Flight Recorder later on, and there are some advantages to using Flight Recorder, and there's some disadvantages to using Flight Recorder. Okay. Anyways, I want to try to get moving forward here because it's otherwise we just won't get through any of this now. But yeah, I think some of the questions will be answered as we go forward too. Okay, so basically what happened is I took a heap dump here, and now I'm going to take a snapshot here. So in the snapshot, I'm basically, we've already identified using generational count that leaking class leaking is the thing that we're actually interested in. I can go through the other things and you can see what they actually are. You can see that they're profile or artifacts in this case. And that's just because the leak here isn't continuous. I do it in bursts. If the leak was continuous, then you could see that it would climb on a more steady basis here. And probably I could change the demo to do that in the future. Okay, but anyways, so the point is we can use the stack trace here to actually figure out, okay, here's the path, right? And you can see dispatch bubbling event. So, and then it's got some Lambda and with some JavaFX event. So, that's my button push effectively. That's triggering the bit of logic that actually causes the whole thing to leak. So not a surprise here. And here's the allocation site right here, right? So that's the constructor. So at this point, I could just go into the code and see what's going on. And as a matter of fact, why don't we just look at that? So we're looking at leaking class constructor coming from leaky model leak, right? Coming from here. So if I just bring this this view over and get rid of all this stuff here. Whoops, wrong one. Let's close that one and bring up leaky. Okay, so here's leaky. Okay, so what do we say? Leaking class. So here's our constructor. Nothing really big in here. And you can see there's a hash map, and here's our leaking field thing. So not really a surprise. These things are going to travel along with this thing, plus whatever's causing it to leak. So just pretty much like what I described in the diagram. Leaking field. It's got a string in it. So that's the byte array, car array things that are happening. Here's leaking model. It basically is just dropping these things into an array list. Again, if we come back to here, you can see, well, we'll be able to find these relationships here, but it basically starts from leaky, which we said was a lambda. Here's my button, right? So it says model leak. If we go to model leak, then it's just going to create some stuff and put that into this array list. So it's kind of boring, but the point is that we've quickly found the allocation site here. If we look into the heap dump, then we can use a heap dump walker to actually figure out more information in terms of like what are the relationships. So if I look at the object view here, there's my leaking class. If I open up my leaking class, now in this case here, I might want to do this a couple of times to make sure that I establish a pattern in terms of relationships so that I know I'm actually looking at something that's leaking rather than something else. And anyways, so I have a leaking class. So here's my fields, right? So all of the things that we expected along for the long ride, leaking field, blah, blah, blah. So that's kind of like boring. So, but what we want to do back here is we want to go and say like, okay, let's figure out where's, how we connect it to a GC root. And as you can see right now, as soon as we trigger something, it's going to do this big calculation where it's going to walk through the heap. Now, one of the problems you have with this tool is that if you don't give it enough memory, then basically it'll struggle to do this calculation. As you can see right now in the bottom corner, it's computing and it's like 30% done right now. So we have to wait a little bit for this to get finished. And then once we're finished, what we can do is we can walk the reference chain back all the way to the GC root, and we can see all the relationships. So we know where the allocation site is. We know where the what the reference chain is around it, so we know what we're looking for. And at that point in time, we can just walk back into the code and debug the code to figure out, okay, we forgot to disconnect here because the scoping is too broad, or something's wrong with our code, and we'll make the fix to our code that will cause the leak to actually go away. Hopefully this will finish very shortly. What are we at? 94, 95. Okay, so if you go into the Visual VM distribution, there will be a comp file in there, and what you can do in the comp file is increase the max heap size, and basically by increasing the max heap size, you can just I blow this thing up. I give it like 12 gigs for my laptop, and I'll make it bigger if I have bigger machines. Right. Okay. So that's an artifact of the profiling. Like I said, I recognize it, but basically it comes from NetBeans, so it's not from us. So you can recognize it. And then here's our array list. So remember, we said this was being hooked into an array list. So, and it's leaky model. So by the time you get to here, you probably shouldn't be seeing anything surprising. And let's just see if we can find a GC root. So, so we're actually a key in a hash map. And there's a guide down here that will actually tell us when we actually hit GC root here, but we should also be able to just calculate where the GC root actually is. Here we go. So again, we can come in here and we can find our leaky class, and we can just sit here and have it calculated. So anyways, here's the GC root right here. So so what it's saying is that this thing here is being on the stack frame, right? So remember, we had the stack frame with the pointers pointing into heap. That's exactly what's happening here. This is an external pointer, so this is a GC root. Okay, and we can still trace this back if we need to. Cool. So with all this information, we can go into leaky and fix it. Sorry?
How does class filtering help you with this?
Well, in this case, as you can see, without the class filtering, I just see everything. And leaky happened to be down here, so I just used it as a tool. Since I knew what I was looking for, I just used it as a tool to help me find it in the list. Okay. Now with the heap walking, I can actually do some other things. So we'll look at the other techniques as we go through the rest of the workshop. Okay. So this leaves us with the first exercise. Okay. So let's see if we can. So I'm going to shut down this so I can free up some screen space. So what I want you to do in the first exercise is just run this web app. Okay, I'm going to just, oops. I'm going to find it. I'll just show you in a second. So what we want to do is you'll just see exercise 1. And what we want to do with exercise 1 is we just want to run the web app. So we're going to compile it and then run it. And then actually, once we run it, what we'll do is we'll run JMeter. And what JMeter will do is it will put some load onto the application. So the application will leak. And so what you want to do is you want to use Visual VM and generational counts to identify what the leak is, okay? And that should take you about 20 minutes. Well, it should take you about 10 minutes if the tools cooperate. So we're going to have 20 minutes to do this. So one of the things I want to do is just show you one thing that you need to do beforehand. So we'll just walk through the directory. So you have the best chance of, did that unzip? Should have unzipped, or did it not unzip? All right, okay, there we go. Okay, so Now, I could have used a whole bunch of different things for getting you to run this stuff, but in my experience, the shell scripts are just brain dead simple. We don't have any Maven issues of downloading the internet or anything like that happening, or Gradle, or some of the other tools which we normally use are just can cause problems that I just don't want. I don't want to deal with problems. We just want you to get to having to look at the memory leak as the problem. So you can see what I do is I call a set environment here, and in the set environment, what I have is this Java home setup. So just set that up to point to wherever your Java install is. So as you can see, I'm in a Linux style environment, OS X in other words. So that's what mine looks like. If you're in Windows, then it's going to look slightly different. Let's just open it up here for you. Okay, there we go. And so you can see that basically the Java home is set right here, right? So, and you just want to be careful that we don't have any spaces, or if you have spaces, that they're properly escaped, because that can cause you grief. Okay, so once you get the set env set up, then basically that means you can just run the compile script on its own if you want to, change some code or do something, or you can just run the app server. The app server start will actually run the compile script for you. Oops, I think it'll do it in Windows also. Just to be sure, just run the compile script, okay? If you have any issues, put them up in the window and we'll try to address them as soon as possible. Oh, sorry, to start JMeter, we're just gonna run this thing here. Whoops, and that's not going to run it. It's going to display it. So let me just Yep. Yeah, it is a directory. Why did it not work? Okay. Okay. So just we just start JMeter. That's fun.
So if you're in Windows, you'll have to write your jmeter.bat file. And just have a look in the chat that I sent. Shows how to do it. I don't have Windows on my machine, so I can't try it out, but it should work.
Yeah. Yeah, okay, anyways, so you can see basically here, this is just going to load test the web app, and so we can just start it. And obviously, since I don't have the web app running, it's not going to connect, so I'm going to get this 100% error right here. But what you can see over here on the side is basically the number of threads. So we're going to try to punch through 2,250 transactions on this server, over a period of 450 seconds. Okay, so just run that and just try to identify the leak. And I'll give you, as I said, 20 minutes to do this. We'll put a break in there and then we'll do it together. So where's my timer? Okay, Stefan. Yeah, okay, yes. Okay, let's see.
If you have a machine with a lot of memory, a good idea is to manually force the GC occasionally so that you get a good generational count. So otherwise you just have to wait for a very long time to see the generational count go up.
Yeah, with profiling, you need a bit of patience. It doesn't happen right away because you're going to have startup anomaly and you're going to have the whatever's happening, basically, that signal needs to become bigger than the startup anomaly. So. That seems to be okay. Not an ideal setting, but it's better there. No.
So Ronak asks a question about the one slide where you say that under rare conditions, only the allocating thread will throw the out-of-memory error and the JVM will survive. Kirk, as far as I know, that's always the case, or almost always the case, that whoever causes out-of-memory error will get an out-of-memory error. And that thread, if you're catching throwable, then you will catch it, but otherwise it's going to bubble up and that thread will die. So I think it would be, it would rather be the opposite, or opposite case where it would not be, it would be very common for that to happen. The thing is that what can happen is that the thread which dies, if it dies, could be the offending thread, or it could be an innocent bystander. So you can have the thread which has nothing to do with the memory leak dying, because it just happened to allocate an object, but that's not actually the thread which allocates the problems. So whenever a thread tries to allocate memory, which it can't, it's going to end up with an out-of-memory error, and that will potentially kill that particular thread, unless you're catching it. But catching it doesn't really help much. All right, what we're trying to do, Dave, is we're trying to find the memory leak. So we're trying to run the profile and connect to it with Visual VM, and then look at the generational count to see which our memory leak is.
Yeah,
there's a question from Madhukar. If you can just have a quick look at that, please.
Which one? Kind of looking down here. Which file defined in the environment flag? Which file defined the environment variable flags in Windows? That would actually be defined right in the app server start batch. Actually, sorry, there's a config file in there that should actually have it in there. So let me take a look. So we should have this jvm.bat file. It should actually be in there. That should define the variables. Okay. There's a whole bunch of different settings for different things in there. I don't think for the purpose of this exercise you should need to touch it. You shouldn't need to touch it. So yeah, getting back to Heinz's point here is that generally what happens is you're going to get a thread is actually going to request an allocation. It's going to fail because there's no memory for that particular allocation. That sends a signal into the JVM basically saying you need to start a garbage collection. The garbage collection process will start and run, and then the allocation will repeat itself. And if it still cannot allocate, then we'll run the garbage collector again. And then the allocation will proceed again. And the cycle will continue until we hit an overhead threshold, or we just can't recover anything threshold. At that point, that thread will be killed. We'll be sent the out-of-memory error, right? Which is an error, not an exception. So errors are different than exceptions. Errors indicate something bad happened in the runtime that is not recoverable, right? So that's a runtime thing, not an application thing. And so unless you do something to interfere with that mechanism, what's going to happen is that will kill that particular thread. Now, under rare occasions, that thread might have been asking for a boatload of memory, more than you have in the memory pool. And as soon as that thread dies, that allocation pressure goes away, which means if none of the other threads have it, they can survive and continue. It'll be fine, right? But so it's only that one thread. But if we're truly full, then all of the other threads are going to run into the same problem. So every single thread is basically going to die with this out-of-memory error. Again, unless you interfere with the mechanism. And at that point, that's when the JVM is going to exit with the out of memory error. But that case I'm talking about is a rare case. I've only seen it like about 2 or 3 times in years. So it's generally something that doesn't happen. Okay. So I've just been slowly going through the exercise myself here, in case you've been watching the screen. There seemed to have been some problem. New version of JMeter is a bit annoying.
Yeah, so Robert, I found on my side that if I manually invoke garbage collection, then it would show up quicker on my machine. But it depends on how much memory you've got. If you've got a very big machine, I've got 32 gigs in my laptop, so there it helps to sort of push it a bit. By default, it gets allocated a quarter of that, so that's 8 gigabytes, which is quite a lot. One thing which catches people out is you need to make sure that your Java process is running with the same user permissions as your Visual VM. So what I had somebody last week in Germany, they were using, they were running the Java processes as administrator, and then Visual VM was not administrator. So it's then you can't see you can't see the local processes. That's the most likely cause for these problems.
Yeah, there's funny things that happen in Windows. Sometimes lowercase, uppercase things happen. And in that case, you need to go in and clean out your /temp directory, and that should correct everything. So I have a question from Arun. So what's the next step after getting Jetty server to run? Then you're going to start JMeter and put the load against JMeter. Well, before you do that, make sure you have Visual VM attached and with the profiler running. Okay, and so start Visual VM, attach it, then get JMeter running, and then start it by pressing the go button, and it should put the load on it. And then you can just monitor. Well, here, as you can see in my window, I have the heap space being monitored, so you can see that there's definitely a memory leak occurring here. And when I go to the profiler, again, if I look, I can see that everything here, in my case, everything's a generational count 18, 17, and then you can see it just drops off the cliff to what I call a normal. So this long tail of ones and zeros and things like that. So it looks almost like a power curve in this case. Okay, and there's another. All right, so that's the. Yeah, okay. With the new G1 GC, does this definition generation still be valid? Yes. These definitions are independent of the collector that you're using. It's really a question of how many times has the collector visited this particular object. Oh, right. Okay. And I have a servlet timer tab in Visual VM that is a specific plugin. Yes, that's a. I can put that. I guess I can put that plugin up on GitHub. It won't be very useful to you because it only works for a MX bean that I actually wrote, and maybe I should just actually uninstall it from Visual VM. Or disable it here because I mean we can go to the plugin. So basically there's a webinar that I do want to do in the future, which is basically how to write plugins. And you can see this one here is specific to this wildcard servlet, right? So it's measuring response times here, giving us throughput numbers and things like that. Why do I only see generation 2 for most objects? Okay, so Jessica, I would say that if you're only seeing generational 2, and that's the largest generational count, one of the things I probably wasn't as clear on as I should have been is, whoops, okay, let's turn that off, click to close. What we want to do is we want to make sure that we start in the org morpe main class. So if you look at all of the classes here, that's the Jetty process that we want to start. And maybe I should have been a little bit clear on that. So this is obviously, if you hit JMeter or you hit any of these other processes, then of course you might have, you're going to be profiling the wrong thing. Just became unresponsive to me. Dan, yeah, that's the problem. You might have run out of memory. And unfortunately, when this happens, we just have to reset and start again. There's nothing else you can do here, is just reset it. Now there is a progress bar on the bottom, so if it is happening to be doing something, and maybe it's doing garbage collection, there should be some indication in the bottom as to what it's actually up to. What memory setting is Visual VM Profiler expecting? I get an error when I click on the memory button in the profiler equals provided memory settings. Memory setting is Visual Profiler. I get an error when I click on memory button in the profiler. Get an error. Oh, okay. That's odd. Manny, I don't know what's going on with you, but if you're clicking on the memory button in the profiler, all you're doing is you're telling the profiler to attach to that, this particular profiler to attach to that process. If you can't attach the process, then maybe it's a versioning issue, but I doubt it. There should be some error that comes up, and I think, oops, that wasn't supposed to happen. Let's get rid of this one too. No, that's for updates. Right. I'd actually, okay, so with this case, I'm not exactly sure why your profiler is not being able to attach. Oh, right. If you go to the settings, I mean, do you have something like this set up, right? So in other words, the two stars, meaning that I want a profile for all classes, and in this case, the array notation here to say that I also want a profile for all arrays. By default, this thing is empty, so you'd be profiler for nothing, which is odd, but anyways. Okay, so so what I did is I ran the application server, and actually, sorry, it's 1:15, so maybe let's take 7 minutes again here, so we can dust ourselves off, and then when we finish dusting ourselves off, then what happens is I'll go through the exercise. Okay. So here's 7 minutes. I need to do, I'll do this during my break because that might take a time. Whoa, that's really kind of funky. Okay, Windows. I don't know if you're there, Onion, and I probably just butchered your name too, so I apologize for that. But Windows, the Jetty server can't see the process in Visual. If Visual VM can't see the Jetty server, it's in your case, it's likely that you're using the same user, and in this case, it's really kind of like a funky Windows thing happening. So what I would do is just go and empty your /temp directory and restart everything and see if that helps. So The most common mechanism for figuring out if a JVM is attachable or not is just to see what's visible in /temp. And really the problem is that with Windows, you have NTFS, which allows you to do uppercase, lowercase, and DOS, which treats everything uppercase, lowercase equally. And sometimes there's some confusion there because the temp names will contain uppercase, lowercase, and they're not recognized, and then the process isn't visible. And yeah, it's kind of funny, but that's just part of the funkiness of dealing, you know, with dealing with Windows. Sorry. All right, here we are. Get rid of that. So
you want to do a quick walkthrough of that, Kirk?
Yep, that's exactly what I want to do. So I can stop the profiler because we've pretty much collected all the data. So is monitoring generational counts. And as I mentioned before, you're going to get this power curve type effect with a whole bunch of stuff at the top of the list. And in this case, you can see I have 34 for a bunch of things, 33, 31, 26, 25. And then it's just sort of like, you know, like I said, you just like, oops, excellent. And it just, oh yeah, then it just like falls off a cliff, and you know, and you just get this incredibly long tail of like small numbers. Okay, so our leak is going to be in here, and if I look through, then you know, my obvious candidates are going to be like tip or tip document. Whatever these things are, we don't really know or care at this point. That's part of the discovery, right? If you look at everything else in here, and again, this is more typical actually than the demo I set up. We're going to see a bunch of things that we're going to recognize that are going to travel along with the leak. Here we can see the composite data support that we saw previously that was dominating, and so it's here too, but this is a profile or artifact. So again, this is just that it was dominating was just a function of how I was generating the leak. Yeah, so this is nice and smooth, so the profile just looks different because of that. And anyways, so we have a tip and we have a tip document. So these are the two things that we really want to try to focus on, right? So what I did was I took a snapshot before I disconnected the profiler, and I went all the way over to here in the monitoring, and I said, take a heap dump. So I did these two things already. And so what I was trying to do is just flatten this by using the break to actually do some of the calculations here. So in the snapshot, we want to look for, well, here's the tip right at the top. So let's start right there. And if I flip through this whole thing, you can see that there's my constructor for an object. Okay, so there's my tip constructor. So that's my allocation spot, allocation site. And it's coming from this tips document, load tips document, tips documents, load tips document, get tips document, and then the wildcard query, do valid query. So we were doing this wildcard query thing, which is a servlet thing. So then all of a sudden you get backed up into Jetty code, right? So it's like execute servlet. In the servlet, we're going to get a document, load it, and as part of the loading it, we're going to create this tip thing, and then, you know, so that's the hotspot for, you know, sort of the allocation path for this allocation site. Okay, which is cool. And you might have noticed that I didn't really give you a description of the application beforehand. You don't really need it. I mean, it's helpful when you start getting into the analysis, but in some cases, I've just pulled one class out of an application, done some work there, sent it back, and like we're done, right? And I didn't have to understand anything else about the application. So it's, you know, I could spend like, you know, generally you go through an hour or two of architectural and discussions and everything about the application beforehand. And in this case here, I just say, give me this data, bang, bang, we're like done. And if I need to know architectural details, then I'll ask later to try to understand what's going on. Right. Okay, so that's what the allocation execution path looks like. If we look at the heap dump itself, and we look at tip, so I can open up tip, and you can see there's just, you know, basically, well, this is a GC root view, but if I look at all objects in terms of the tip, you can see there's just, yeah, there's like more than 500,000 of instances of this particular object, right? And so if we go through it, we can see, well, there's fields, and our fields are, well, there's a string, and we have a static reference to this particular class loader. So this is going, you know, back out, like we said. And if we look at the references to see what's going on, you know, we're basically in an object array with this an array list, And I'm ignoring this one up here because that's a profiler artifact, and you can recognize that by saying it's or.netbeans. Okay, and also here's the tip right here, kind of odd. And this is into another object array, element array list, which is a referent, okay, which is in a tips document. So you can see we're getting into things that sort of match the allocation stack trace. And this is a weak reference going into, okay, so this is, sorry, I went into down a path that I shouldn't have. Anyways, the point being is that we can walk all the way back here and start getting an idea as to, you know, what's actually going on here. Or I can look at, again, I can look at the GC roots here. And you can see that, okay, so all of these things are basically pinned in by some frame. Oops. So look at the value. And I'm just going to flip through here. Let's see how far we can go. There's a concurrent hash map in here. So we're evaluating a concurrent hash map. We're in another concurrent hash map. So we're in a table in a concurrent hash map. Oh, and then we finally get down to a static. So static is going to be a GC root here. And we can open it up, and that puts us into an object array, and it's an element day and vector. And that's basically down. So you can see what we have is we have a class which is holding on to a static collection, which is a concurrent hash map, which seems to be holding on to another concurrent hash map, which is, so you have these nested collections of collections, right? And it's a mess. It's a real mess, and it's a real good place to hide a memory leak in these messy things, okay? And so if we go back now into the code, and I'm going to probably do this the dumb way. Oops, hold on. So if we go into source com, code work, tips, into the servlet code, because that's where we started, right? Remember, we started the execution path with the wildcard query right here. So I'm just going to take a look at this, and you can see, oh, sorry, we started with the simple query. Simple query. So if I look at the simple query, basically, here's my do get, and you can see what happens is that it's going to forward the request right here. Right, so in this logic here, basically what we're going to do is we're going to forward the request, and then we're going to take the result set and convert it into an HTML document somehow, and then make sure the document gets pushed back out to the browser. Okay, so this is all kind of like really boring. So our request actually goes into the wildcard server, and you can see, oh, there's some tips documents. Remember, we ran into that, right? There's our new tips document. And as we go down through here, we're saying documents, get tips document, and we seem to be getting this iterator, and we're iterating over the tips documents, and we're using this actually to form a query, and then we're going to execute the query and then get the results back, and then push the answers out to a browser. So, but the point is that we're in sort of this area here where we have to look at this thing called, I guess, tips documents to see what's going on here. And so we can just, as you can see, walk through probably using better tools than what I'm using right now. But we can walk through this whole thing and we can just like figure out what's going on. So here's our get tips document. Remember we saw that? I'll just remind everybody here by bringing up Visual VM. Where's our snapshot? Get tips document, load tips document with a string as a parameter. There's our get tips document. So tips document is equal to null. So for our array list here, so remember array list was involved here. So it's like, okay, so if that's null, then we want to load it. and we're going to load it and from here. So we're going to get it some file name from someplace. And in this case here, we can see that we have a tips document, and we're reading this document here, and it looks like probably some XML document that we're creating a new tip. So there's our allocation site right there. Okay. And then, so let's take a look at tip. Oh, and we have this funky thing in here, which is keyword, extract keywords from. And if I look at keyword, where's our extract keywords from right here? It seems to be going through the document, and we can go through the logic and everything like that. I'll compress this and just say, like, effectively what we're doing is we're taking all of the tips we're creating and taking all the keywords from the sentences after we clean them a bit, and we're stuffing them into this hash map, right? So here's our static concurrent hash map, all keywords. And what we can do is just relate this back into the heap dump. We can take a look and see static all keywords. Okay, so you can see how the profile is sort of mapping and matching with what's going on in the code here. So if we get back to actually what's causing the leak, I mean, this is the thing that's leaking. The tips are leaking into this thing here. The question is, like, why is everything getting loaded so often? Whoops. So if we go back to servlet, so wildcard query, you can see that the tips document is being created every single time we do a query, which means that if you think about it, when I do the get, remember that said if it's null, then load it. Of course, it's always null, so it's always loading it. And then unexpectedly, somebody's loading a static map from the constructor of the tip. And so you get this weird combination of things happening, and all of a sudden, the tips are leaking. Okay, so obviously you'd want to correct that logic, and once you correct that logic, then you would get rid of the leak in this particular application. Okay, so I'll try to let that sink in for a second, and I'm not going to be able to follow because no, there shouldn't be any extra plugins or setup that needs to be done in Visual VM. As long as you get the downloadable version from the website, you should be okay. And Mateo is saying, I see more candidates apart from tip class, but not in Java standard packages. Is that class been chosen because it is in the package of example one project? I could have chosen tips document, and I probably would have unwound to the same place, but I'm actually going to pick tip and tips because if you look at the profile, again, if we go back to the profile, and you look at the generational count, tips and tips document are domain objects. There's stuff that I've written, and they have the high generational count. So that's why I chose one of those two. Okay, does that make sense? Heinz?
Yeah, it does. Dan has a question. He can't expand the classes in Visual VM. Any idea what could be causing that?
I can't say that I've ever run into that particular problem where you can't, where the drops down don't expand. In this case, it's got to be for some reason Visual VM was unable to collect the information. That's typically due to an internal error within Visual VM, and this is typically, it might be that there wasn't enough memory. It might be that you need more memory to work on this particular problem. It might be that you have to increase the memory and just start again. And I'm sorry. I wish
it says that it cannot find the source code as well.
Sorry?
It says that it cannot find the source code, which I'm not sure why it would need the source code.
Oh, right. Okay. So Visual VM is built on top of NetBeans, and this profiler is also in NetBeans. So it's expecting to have the class paths and everything set up as a real project. So there's certain functionality in there that doesn't work in Visual VM but hasn't been disabled. And so, so if you're looking for source code, then there's certain places, I can't remember where they are exactly right now, but there's certain places where you double click on things and it's gonna want to look for source code. And that just means that you've you're going to a place and trying to get to the tool, not your fault, but to do something that it's not capable, this Visual VM is not capable of doing. Okay, okay, so you're gonna get more chances at this, and I'm simply not able to expand the classes. So if I double click on the class, I'm not sure why it would be asking me for. Honestly, I haven't done this for so long, or run into that so long, I just simply forget. I know there's certain cases where you click the right way, all of a sudden, this is gonna be a problem. I have 4 gig free. Okay. Maybe Dan, what you can do is take a screen snapshot and somehow send it to me, and maybe we can look at it that way. If you email it to either, well, email it to me for certain. I might not be able to look at it till for a little bit, but I certainly want to try to figure out what it is that you're actually doing here. Okay, should we go forward? So we're running out of time.
Okay, so Anjan, to make sure that the profiler works, you need to specify sort of a pattern that's going to be used for matching. So unfortunately, I don't know why Visual VM doesn't by default have this pattern.
Yeah.
But do you want to go to the page again for a second, just to show how it should look?
Yeah, this is really an unfortunate thing. Hold on. Whereas I can't see because of the. I tried to hook up another screen and I was not having much fun with it. So like I'm gonna have to do this. I'll just do it this way. Yeah, I honestly don't know why they have done this with Visual VM, and this is I wouldn't call it a bug, but certainly a feature flaw in my mind. So let's like just attach this so we can get to the profiler. Attach. Okay, we should be opening anytime. Should be opening.
Maybe it's hung out of memory error.
Yeah.
Should be attached to something else.
And it's hung trying to attach the application, and I don't know why, but let's see, JMeter. Let's try this one here. I'll just attach to JMeter.
Yep.
There, okay. So now we get to the profiler, and you see in memory settings, it says define class to be profiled. So this is the pop-up that you can actually get, to look at it. But for some reason, I just don't know why they just don't set it to something like this. That to me, that's a reasonable setting to start with if you don't know anything. If you know something, then you can apply heavier filtering if you want to. And if you don't, have any of this set up and you try to attach, you get provided memory settings are invalid. But even if you get something like that, right, and you attach, now you can attach, but I mean, you're only going to be able to see arrays. So all other information is basically going to be missing. So let's kill that. Okay, let's see if we can move forward then in terms of next. So object profiling headaches. Memory profiling is currently very expensive, not suitable for production, and may be difficult to use and test. I've written custom object profilers that work in production environments, but you know, it's still tricky business, right? Memory profiling will distort the allocators and will cause the optimizers to miss opportunities to eliminate allocation sites, and that can be a problem, right? So if we want to try to avoid these things, the alternative technique is going to let's snapshot the heap. And as I mentioned, you know, earlier on, this is going to give you like a single point in time view of what's going on, and you know, so it suffers from those particular problems, right? And it is memory intensive, but you know, it can still give you all of the same information. So let's try to triage the leak just using a heap dump without the generational counts and all of this other information that we get with Visual VM. In this case here, what we're going to do is we're going to look at a few more definitions here. So I'm going to introduce this notion of shallow size, right? So if you look at the shallow size, then that's the amount of memory consumed by the immediate fields of an object. So it's going to be the header plus, you know, whatever the immediate fields are. So if we start doing this calculation, we're going to see size of contact is going to be an object header plus int plus padding plus 2 times reference, size of reference, whatever that is. And so we can add this up and we can generally say, okay, so when we do new contact, we're going to burn 40 bytes of memory. Okay, so it's a fairly typical thing. If we look at retained size, then what we want to do is we want to look at the deep. We want to do like look at a deep size of this particular object, right? So that's going to, so the size of contact in this thing is, in this case, is going to be the size of email, excuse me, plus the size of name, right? So it's going to basically give me everything that this thing is pointing to. I'm going to run through the calculation here. But you can see you end up with the number of 90 bytes after you run through the entire calculation. Awesome. Now we also have this idea of dominators. So I have this object graph over here, and you see I got some green things, red things, black things, gray things, and everything, and a bunch of pointers. So this represents some state of heap where we have data pointing to other bits of data in our heap. So this is our complex object graph. And the dominator object is actually going to be the red thing, the red object, right? So that's any object in an object graph that must be passed through in order to reach any other objects. And so in the case of a dominator, you're going to create this pinch point. So I'm going to have this very narrow reference path that I have to pass through in order to get to data. The immediate dominator is going to be the dominator that's closest to the target object. And so the red guys could be immediate, it will be an immediate dominator. The green could still be a dominator, but of course it's one off, so it's not the immediate dominator. And then we have this notion of a dominator tree. And so what you can see is that the only way to get to all of these black objects is that I need to go through the red object, right? And so I have to go through this immediate dominator. And depending upon the tooling's interpretation of dominator, what their definition is, the gray object may or may not be included in that set. Okay. So in terms of calculating the retained set size, what we're going to do is we're going to ask the question, okay, red object, how much memory is being held on to because you're still alive, right? So how much data is only referenceable through this immediate dominator, okay? And we're going to use this as a diagnostic again in the static heap. So we're going to acquire a heap dump, And we can do this in a number of different ways. So we can use the heap dump on OutOfMemoryError, or we can use a J command and we can say, get the heap dump that way, or we can use JMaps. So there's a couple of different tools we can use. Actually, Visual VM is another tool we use to get a heap dump. And then once we get the heap dump, we're going to use some tool to calculate what the dominator trees are. And once we've calculated all the dominator trees, we're going to investigate the dominator with the largest retained set size, because that's the most likely source of the leak. And if it's not the leak, then repeat with the next largest dominator. Okay, remember this is a snapshot, so you could be momentarily, one cache could be momentarily big, but then, you know, after the next GC, it's cleaned up for whatever reason. So it's possible to have something really big show up in this list that actually isn't your memory leak. And to use the heap dump, you actually have to have more context of the application. You could see we could basically go through the application with and find the leak using the generational count. With this, you're going to have some knowledge of what's going on in the application so you can sift through the dominators. And unfortunately, this gives you a bias, because this is where you get into the problems, because the cache is always going to be, generally the cache is always going to be a candidate leak, right? I say often, that word should really be always. And people are going to look at it and say, ah, that's my cache. Of course it's a dominator, and I'm going to ignore it, even when it is the thing that's actually leaking, right? So be careful here, don't be tricked. Okay, so I'm going through any questions. It is 10. So are you using Java 10? 142. Ah, okay. Yeah, so these things should work in 10 and 11.
Kirk.
What's that?
Don't worry, I'm dealing with this stuff.
Okay, yeah.
It's just this tooling, trying to get the tooling working.
Yeah, absolutely. I understand that. Thank you. Okay, so let's look at the dominator trees within Leaky. So obviously in an exercise this small, we're pretty much only going to have one dominator, but you know, let's have some fun with it anyway. So I'm going to start Leaky up again, and yeah, we do have this other noise in it, but that's actually good, right? Because that'll just help confuse a bit. So let's just run this like 3 or 4 times and just get a bunch of stuff in there. Okay, so now we probably have a big GC running, and that's why we get this pause thing and stuff like that. Okay, cool. So now we've run that quite a few times, and so what we can do is we can just bring up some sort of terminal window where it is. It doesn't really matter. And so I can do a J command -L. Right, and oh, we have Jetty and all kinds of things running, but it doesn't matter. This is the thing that we want. So again, so what are we going to do here? We're going to J command that, and let's just run help here, because this will tell us again what we can actually do. And there's the command I need to use for heap dump. So instead of putting help in there, I'm going to put heap dump in here, and then I'm just going to put like leaky.hprof. Okay, so there's my heap dump. And we just run it. Now, J command can only be run locally. So if you're running up in some sort of server environment, you're going to need to run this local on that particular server environment. And when you get into certain containers, this can get tricky. Okay, cool. So we have leaky.hprof, right? So now I need a heap dump tool to actually to take a look at this and calculate dominator trees. I'm going to use Visual VM, and we can also look at it using MAT. So up we go, start it up, applicate. Oh, so I don't need to attach. I just need to do a file load. Where's desktop? Exercises. Oh no, it's in Leaky. Sorry, it's in the wrong place. And And let's take here. So there we go. Let's open it up. So we're going to load the heap dump. Hopefully it's not too big, so it won't take too long. It looks better already. Okay, excellent. Okay. Right. There's JVisualVM usually is included in the JDK distribution up to JDK 9. JDK 9 is no longer. And VisualVM would be the one downloaded from GitHub. Okay, so basically we can have the object view here, and when I look at all objects, I want to look at dominators. So now, as you can see, what's going to happen here is we're going to calculate the retained set size, and this can take a wee bit of time because it has to go through all of heap and do all of the calculations. So I'm just going to let this run for a bit. And let's see what happened to all my stuff. This thing is in the way again. Here we go. Sorry, it was right there. Okay, so I'll let it run for a bit, and I'm just going to finish up what's going on. A few more slides while we're waiting for it to compute. Okay. So on a slightly different topic here, I just want to talk about class loader leaks. It's different, but sort of the same. Again, it all boils down to I have a GC root holding on to something, and I need to find that path in order to understand what it is that I need to disconnect in order to get the leak to stop. So with class loader leaks, the class loaders are going to contain references to all classes loaded into the JVM. And you know, there's the classes that are also going to contain references back to the class loaders. And if you have statics, then there's going to be references from this combination into the statics and back, obviously, and to maintain these things in memory. And what happens is that when the class loader leaks, is some of the stuff just doesn't get unconnected, and so it's always considered to be a GC root. And so when we try to garbage collect the stuff, it just doesn't go away because there's some reference chain in there. So in Java 8+, when we load a class, the metadata is going to be loaded up into metaspace and class space. And I don't really want to get into the mechanics of it, just to say that it's all being loaded into one chunk. And the chunk is going to be garbage collected in one shot. In other words, if I have a reference from someplace into a metaspace chunk, that metaspace chunk is going to live. And if we collect more classes as we keep loading classes and stuff like that, and we get more growth in metaspace and meta class, then our native space is going to grow because these are native data structures that, well, they're sort of partially tracked, so you can have a little bit of tracking of what's going on there. Again, I'm not going to cover that too much today, but essentially what happens is that this stuff just keeps growing and growing and growing, and then eventually your process gets too big, and you get all of the issues associated with that. So in terms of class loaders, in 8 we have a bootstrap class loader, which gets the basic classes that comprise of Java. We get an extension class loader where we can add extensions to Java. We get a system class loader that comes off our class path. And then if we're running application servers or things that use their own class loaders, like if you look at Apache JMeter, for example, it loads all of it puts the load test into its own class loader. And so it just loads all the classes needed to run the load test in that class loader. And then when the test is over, but in theory, their custom class loader should be garbage collectible and it should go away. So the first reference to a class will cause the class to be loaded into memory. So how this all works is a little tricky, and I don't want to get into all the details and intricacies of it, because again, you don't really need to know it. The only point I'd like to make is that the normal class loading specification is that class loaders are delegating. So in other words, if I'm in a system, if my thread is executing within the context of a system class loader and I say new foo, the first thing it's going to do is ask the extension class loader, do you got a foo? That's going to, first thing it's going to do is say, Bootstrap, do you have a foo? And then it's going to delegate all the way back down to system, right? Because, you know, extension and Bootstrap are not going to have foo. It's probably going to be on the class path. So then it's going to load it from the class path. When you get into custom class loaders, then all kinds of weird things happen. Like, for instance, OSGI doesn't delegate by default. JE doesn't have a class loader specification. You get people who don't understand the thread API loading classes dynamically, and they do it incorrectly. And there's all kinds of funky things like this that can happen. In Java 9, we have modules now, and modules now change the rules as to how these class loaders are actually, you know, ordered in terms of lookup. So a module will be in its own class loader, and its rules are well defined, but, you know, so you'll see what happens is that there's some, you know, the extension class loader is now the platform class loader. System class loader is now the default class loader for modules not included in the JDK, right? So in terms of its ability for creating new sources of memory leaks, I mean, we're still looking at modules and figuring out, okay, so, you know, I mean, they've done a pretty good job with it, but, you know, there's still, if you miss one thing, basically, you're going to have this type of leak. So I'm going to skip over this and just go back to here. Static variables will always be considered live as long as the class loader is live. That implies static variables will be considered GC roots. And that implies any object attached to a static will be considered live. And so you can get some, so we had some discussion about this in terms of inner classes and things like that. So for instance, if you have an inner class referencing a static, you're good. But if you have that, if you have the static somehow referencing something in the inner class, then that static is going to be GC root and the inner class is going to live. And typically where we see this being a problem is that if the inner class, well, the inner class will have a reference to the outer class. And then so it's not only the inner class lives, it's the outer class lives along with it. And, you know, so that can cause unexpected problems. Generally, what I find is that, you know, a real good recipe for, in general, is just narrow the scope of all your variables. A lot of these problems just simply go away when you start narrowing the scope of your variables. And as Heinz will tell you, if you listen to him, he'll tell you that a lot of the concurrency issues simply just disappear when you start narrowing the scope of your variables. And that's really the answer here, right? So if we look at this particular example here, we can see I have an inner class implementing custom level, which extends a level class, which comes from the Bootstrap class loader. And if I try to unload all of the red stuff and garbage collect it, then I have this back channel that creates a dominator tree. And if I can find this, then I can figure out what's broken and then fix the code and make this go away, right? Right, so that's what we want to do. Few more notes on metaspace. Metaspace size is uncapped. So the leak will continue to fill native memory until you basically run the machine out of memory. And as you hit certain thresholds, you're going to get performance degradation. You can cap, and we do recommend that you cap the size of metaspace. Okay. And when you reach that threshold, the JVM will fail with an out-of-memory error. In terms of getting information on what class loaders are alive, before Java 8, when we had permstat, you could use JMap, permstat PID. You can still use this in Java 8, and it will give you a list of the live of class loaders. Generally, we're going to load, exercise, unload, run the garbage collector a couple of times because there's going to be alternate reference types in there, so we need to get rid of those also. And then look for the classes that should be there. And if you can get a heap dump, then you can walk back and try to trace through to figure out, okay, you know, why are these things actually connected when they shouldn't be? There's also native memory tracking, which is outside of the scope of this particular webinar. I will look at native memory tracking in a webinar I'm putting together. So hopefully March we'll have something for that. But anyways, there's some tools that we can use to actually identify this using native memory tracking, which is helpful. You know, so unfortunately, class loader leaks are on the boundary of both a native memory leak and a Java memory leak. So it's sort of not clear where it falls. Right. So anyways, so that's all of the slides I have to present on the whole thing. So basically, what I want to do now is just go back and look at the dominator tree as we've calculated here. And so here's all our dominator trees.
Kirk, there's a question from Vivek.
Yeah,
Is
sure.
it a good practice to compare heap dumps to identify a leak by finding the dominators and the difference?
Yeah, you can do that also. It's a very expensive calculation. I generally don't do it myself, but it is actually a good thing to do. If you have 2 or 3 heap dumps, I would just find it in one, find it in the second one, find it in the third one, and you know, if you have like 3 hits on the same stuff, then that increases your confidence that you're going after the right thing. Okay, so in terms of retained set size, no surprise, leaky wins. And as you can see, I can just again do the same type of heap walking that I did before to actually walk you through everything. Okay. Now, let's see if we can get MAT to work also, because it'll do the same type of thing. So let me close that down. I'm going to close that off. And yeah, okay. Not sure what's going on here. So oh, hold on, there it is. Okay, so here's MAT. I'm going to open the heap dump. I can actually acquire a heap dump with MAT directly. So you can't see that menu because it's on a different window. So I'll bring this over here just so you can see the excitement of loading a heap dump. Isn't that fun? Okay, here we go. So progress bars are so much fun to watch. Are there any questions in here? So you guys can start asking questions. Yeah, we will look at, we'll take a quick look at mission control JRocket also in a hopefully very shortly.
Okay, so what are the scenarios when the GC pauses would take too long time?
Sorry?
Take a long time. There's a question by RV Arun. He says, what are the scenarios when the GC pauses would take a long time?
There's only a couple of things.
I'm not sure if it's part of this particular
long time. There's 2 basic reasons why you get a long GC pause. The garbage collector has a lot of work to do, or the garbage collector is being interfered with. Okay, the most common cause of having a lot of work to do is that we have a lot of things to copy, right? As in we're doing a compaction or something like that. Okay. The thing that interferes with the garbage collector in terms of interfering with it is two things that happen. One is page coalescing at the operating system level. If it's frequent, then it's most likely going to be an overloaded I/O channel. So what happens is at the end of the GC cycle, the prof data is going to be written, and if your I/O channels are busy, then that write can get stacked up into a queue, and if that happens, then you're going to be spending a lot of time writing data into a queue, or well, sitting in the queue, and the garbage collection is not going to finish, so you're not going to progress. Okay. Sensum will actually identify that for you. So it has analytics in there that will tell you when that's happening. Okay, so we're still waiting, and somebody wanted to look at slide something or other. Jessica wanted to look at slide 83 again, and I'm very happy to open that slide again. I just have to.
I think, Kirk, let's just finish this MAT first and come back to that. We
I'm
have
waiting
enough
for
time,
it
I
to
think.
parse the heap dump
okay,
now.
Sure. Go for it.
Yeah,
go for
so
it.
so that's why I'm just filling in dead time here while we're waiting for it to parse. As you can see, it's taking a while. I can probably help it by shutting things down, but anyways, we'll let it go. Okay, so here we have, okay, so let's go over the time again. So I don't exactly know what you want, Jessica, here, so I'm just gonna go through the whole thing, right? So the way application class loaders have been used in the wild is slightly different than the original design, and this gets into this funky use case where they didn't expect application class loaders to be loaded and unloaded like we can do with application servers. And other applications may decide to just throw away everything by just loading everything into an application class loader, and then when they're done with it, they unhook it from the system class loader somehow, whatever that looks like. And then it should be garbage collected. And that opened up all of these edge cases where you can see that I have these back pointer back chains into something that's actually considered a GC root, right? Like the Bootstrap class loader is actually not a real class loader, it's a pseudo class loader, unlike the extension system or application class loaders. And the JRE code gets, basically the JDK code gets loaded there. And so if I do something, in this case where I take a, Java util level, so that's a logging thing, and I extend it with a custom level, that's an interface, and I implement the interface, then I've created this sort of backdoor chain. That means that when I go to garbage collect this data structure, if I take away the pointer between system and application, in other words, I say unload this application, then what happens is that the garbage collector is not going to be able to garbage collect. And so if I reload the application, then I'm going to get a whole new set of all of this stuff. If I unload and reload it, then I'm going to get another set. And you can see I'm just going to start consuming more and more and more memory until eventually I'm just going to run out of memory. So I don't know if that's helpful. I hope it is. If it isn't, please do let me know.
Here's the good one. Whilst you're waiting for this to happen, mine is getting an out-of-memory error. GC overhead limit exceeded.
What's the good one? Sorry?
Money is getting out-of-memory error. GC overhead limit exceeded.
Oh, that's cool. Right. So if you're spending 98%, more than 98% of recent time in GC, then it's just going to say, you know what? I'm just spending all of my time trying to get memory for you, and I give up. I just give up. Okay? And that's really all that's saying. So that's one of the thresholds. So one of the things we've actually done is we've seen a system actually spend about 96 or 97% of its time in GC, but not over 98%. And at that point, you're not making any forward progress. So we've actually gone back and redefined. And I've only done this once ever, so it's not, don't do this at home. But I redefined the out-of-memory threshold to be 95%. And so when it got to that case where it was I'm just not recovering and I'm not making forward progress, but I'm not quite meeting the threshold. So at that point, it basically just said, okay, bang, let's just blow out of here. Let's just shut down. Okay? So should I go to the class loader leak here? So I'm going to go to the leak suspect report. I'm just going to finish up by having it print that. So I'm going to make this bigger, so hopefully we can see things. And there's a whole bunch of different things you can do with the tool. But you can see in the case of leaky, what it's doing is It's basically giving us a shallow size of 40 bytes, right? And a retained size of 824 megabytes for this particular class. So we can look at the dominator tree. And you can see that leaky comes out right on top. And again, you can do the same things you can do with Visual VM. Is basically we can walk back. In this view, you can see it's just a little easier to see what's going on. But you can walk back through and sort of get a structure, an idea of what the structure is. Now, see, we're not we don't, in this case, we don't know that leaky is actually leaking because we don't really know its generational count. We can just guess that it is. We have no idea about where the allocation site is for this particular object. We'll have to search through the code and find it, right? So we don't have all that information, but at least we have a good idea of what's going on, and we've gotten it by just simply taking a heap dump, okay? And we can find the other stuff. It'll just take longer, a little bit more experimentation, but we can still find it, right? So there's other things we can find in here. So you can see basically in this case, it's identifying the leak. Right, and it's giving you a view of the tree here. And saying what's being accumulated. Okay, so leaking object is being accumulated. Okay? So what I would suggest that you do in this particular case is let's go back to exercise 1. I'm going to change this up a bit. And you already know what the leak is and everything like that. But let's just use, let's get the heap dump from that application. So let's just run it again without Visual VM running, or you can run Visual VM to watch the heap. But then get a heap dump, right? Either by using J command or by using Visual VM. And with Visual VM, when you get the heap dump, what you can do is you can actually go in the process and you can say save the heap dump, right? So the heap dump will be part of the application tree. Sorry, I don't have it up to show you. But anyways, you can save it and then you can load it into MAT, and then you can see how MAT exposes this leak to you. Okay? And then after we do that, what it'll do is we'll hopefully have enough time, we'll be able to look at mission control, and then we'll do the same thing. Okay, so I'll give you, say, 15 minutes to do that, so it should be quicker to do, since we shouldn't have as much tool fiddliness here. Everybody happy? Oops. Oh, that's funny.
Kirk, if I understand your slide 83 correctly, somebody overrides level.class and specifies a custom level for his logging, for log4j or whatever.
Mm-hmm.
And that level is now used within the logging framework. And because this is now a general logging framework, it's loaded as part of the bootstrap. And so as long as that custom level is in the bootstrap, the custom level can't be unloaded. Therefore,
no, the
application
the custom level is actually being loaded, is not actually loaded by the bootstrap. The bootstrap will not load the custom level.
Sure. No, of course not. Of course not. The custom level is part of my application class loader. But what happens is, because the custom level is used by the logging system, which is loaded by the bootstrap, as long as that my class $1.class, which is our custom level, exists, the class loader can't be unloaded either.
That's correct.
Right.
Yeah, you can't if you have a class if you have data in memory for a particular class, there's a pointer from, remember, if we go back to the slide, all the way back here. I know it's a long time ago now. Where is it? If we go back to this slide here, yeah, I'm going to go through a lot of crap here. A second. Yeah, this one here. Okay, so here we go. You see what's happening here, right? Part of the object header is that, this is just an array of bytes in memory, like from object header to the ref, and the int and the byte for that matter, right? It has no idea what this is. So in order to get the template to know how to map things so it knows what the fields are and where they are and everything, it uses this class metadata. And so the object header actually has a pointer into metaspace, and that's the class metadata. So I can get the metadata, and as soon as I have the metadata, then I know what the fields are, and I know what the offsets are for those particular fields. So I know that I have an int at offset 0 from the header. And I know that I have a ref to a byte array at, basically offset 8 from the header. Okay, and that's how it figures out what's actually in the object. So as long as this object header is here, then of course I'm gonna have a pointer to the class file, or the class metadata. And as long as the class, and if I got rid of the class metadata, then obviously I wouldn't know how to decode what this thing is. So that would be a problem. So as long as there's an instance in memory, I need to have the class metadata. And as long as I have the class metadata, then I'm gonna have this back pointer here, this purple back pointer back into heap. And so you end up with some sort of entanglement that can cause a memory leak in some instances. Now, they solve a lot of this by using what's known as weak references. And so there's a lot of weak references that are used here that actually say that if there's no instance here and I only have this purple thing pointing back, and that's a weak reference, then of course, I'm not going to hold on to that thing in memory, which means I don't have anything holding on to the class metadata space, which means that all could be garbage collected at that point. Okay, but if they put a strong reference in there instead of a weak reference in the wrong place, like for instance, if you come down to this particular instant here, and you can say, okay, well, I have no instances of this particular class in memory anymore, right? So I don't have any instances here, and the level to level was like a weak reference. Then of course, when I got rid of the strong reference between system and application, there's no strong reference holding on to any of this, and then all of that would be garbage collectible. So it's a little tricky, I will say that. Okay, Stefan, hopefully I got the detail you need there. Well, I mean, so everyone's complaining about JDK logging, and they go to log, say log4j is better and all that stuff. And in my estimation, I don't like any of the logging frameworks per se, so I'm not really happy with any of them. But the JDK does something from a design level, which is quite egregious in that it has its superclass knows about its subclasses, and that's just a recipe for a memory leak of this type. Right? Your superclasses should never know anything about your subclasses, your child classes. That type of relationship is, what do we say, verboten? Did we get that one right, Heinz? Forbidden.
Verboten.
Yes, there you go. I don't know. I always like the German word for this better than any other language. It sounds more definitive, right?
Well, you need to understand the culture, right? So in South Africa, everything which is not explicitly allowed, which is not explicitly verboten is allowed.
Right.
In Germany, everything which is not specifically allowed is verboten by default, right?
Right.
And in Greece and Bulgaria, everything is verboten, but nobody cares.
Yeah. And that's the beauty of Greece. I mean, if somebody cares, then generally people care. I don't know. I just find Greeks don't like annoying other Greeks.
Yeah, we try to keep out of each other's hair because you tend to get shot if you do something silly.
I've never found that to be the case, but I just find that Greeks they just go out of their way to be friendly or whatever.
That's
so they
why.
allow you to do anything if there's a problem. It's usually a polite discussion. Okay, so 2 minutes. I should be done. I should be done here. Am I done? Yeah, we're done. And close that. Why is it still running? Oh, wow, look at that. Huh. Got backed up, did it? I'm going to see some failures too. It's really weird. Normally this runs clean. It's just the webinar software that's killing it. I mean, this was specifically tuned to run clean on a bare machine. Okay, okay, we got enough here. I can just stop this thing. Okay, so now what I'm going to do is, oops, and start jar. So we need to heap dump that, right? So let's get this one here. What do we got here? I think that should do it. Wow. Okay, that's fun. I type in the wrong number? Looks like I typed in the wrong PID, which is not cool. No, I didn't. Is it not going to? Oh, okay. So, okay, so time's up. I'm trying to get a heap dump out of this thing now, and for some reason, I get the feeling it's just going to bloody well fail. And this might be an indication that, oh no, it worked this time. Lovely. Okay. So let's go to, so we looked at this thing in Visual EM. Let's look at it in MAT. And it's still shutting down. I don't want this running, so let's just be cruel to it. Goodbye. Okay, where's the MAT running? Is MAT not running anymore? Huh, okay. MAT, no worries. Oh, and that starts up over here. Okay, so we got it running. I'll put the timer aside. 31. Okay, so now what do we got here? It's, okay, well, let's see. Let's open heap dump. And we need to go to desktop. Exercise 1. Here's their jetty.hprof, so we can open it up, load it up. Okay, so let's take a look at this question. Okay. Thanks. Oh, okay, cool. Hey, we love Greece and Bulgaria. They're really good. Okay, yeah, so so Manny, what do I mean by the diagnosis? Just go through the diagnostic step again. So basically, what we want to do is just run the application that we ran before, get the heap dump, and just look at what the Dominator tree view gives us. Now, I mean, obviously, it's not as much of a surprise because we know what the problem actually is. But to be fair, we do this on a fairly regular basis. Is what we'll take a problem, we know what the answer is, and we'll just use a bunch of different tools and just look at the same problem with all the different tools, because sometimes what happens is we get into situations where we don't know what's going on, and I'll sort of have an idea, and that idea will say, well, you know, if I use this particular tool in this situation, it's probably going to get me to the answer faster than if I use these other tools, right? So when I say I like all the tools, I do. I just like them in specific circumstances. You know, I might use one over the other. And it looks like, again, it's taking a little while to load this heap dump. We're at like 52%. So I'll take more questions while, yeah, same process, different tools. That's exactly what we want to do. Okay, so maybe while we're looking at this, what I should do is I should take, we should really, well, 60%. Okay, we have time. So what I'm going to do is I'm going to just bring up mission control. Now in Java 8, we have a licensing issue with JMC and Flight Recorder. In that you can use them in test environments, but you can't use them in production environments. Okay, so a little bit of history behind this is that with mission control, flight recorder. What we had was a technology that was developed for JRocket, the JRocket JVM. And what happened is that come Java 8, what they did was, well, Java 7, they started integrating the flight recorder capabilities into the JVM. So internal to the JVM are a whole bunch of ring buffers that collect data, right? Or you can collect data. So what flight recorder will allow you to do is from the command line or from JMX or from a tool, it'll allow you to actually instrument a JVM and collect this data, record this data that's being collected by the JVM, right? And then that'll dump it into some file in some format, and then you can visualize it with mission control. And the visualization within mission control, in my opinion, is exceptionally messy. But you know, that's my opinion. Maybe other people like it. So, and right now it seems to be hung for some reason, so I can't actually progress. Don't know why. Maybe MAT is holding it up with the webinar software. Who knows? Oh, we're at 100%. Okay, so this is doing some calculation, and then after it does the calculation, we should get the reports. Okay. Anyways, going back to mission control. Yeah. I want to cancel this, and it's not letting me cancel this for some reason. Okay. Well, ultimately, I can control it, right? That's kind of weird because I've never had that happen before. So don't do that again, please. Okay, can we cancel that? No, it's just not going to, this is, just love it when tools don't cooperate. Okay, let's go back to here and see what it's doing. Did I actually, I thought this was done. Why did we come back to 54%? Yeah, so I'm probably having memory issues here, and that's causing difficulty. And because my CPU is pinned, I actually don't have any headroom for getting any of this to work.
Can you have a quick look at the questions? George has an issue with JMeter.
Yeah, I noticed that. It doesn't seem to be affecting the load test, and I don't know why it's happening, because these are the same JMeter scripts we've been using for quite some time for this exercise. So I'm going to have to dig in afterwards to figure out why, because I'm having the same thing happening. That said, it seems to happen after the after the whole process has been finished, so that, you know, it's putting the appropriate load on the application server. So I would just say ignore it for the moment, and I'll definitely reach out and post something if I find something worth notable reporting. But and I will have some screen casting of the exercises. So that you can actually, after you've done them, like, so the takeaway from here is that you can finish the exercises on your own. And then I'll have a recording showing how I did it. And people sent me email last time saying, like, here's my answers, here's how I solved the memory leaks, and here's my opinion on different things and stuff like that. And I was very happy to answer and engage in conversations with them. So you know, so at the end of the webinar, do feel really, actually, I would say, I really encourage you to reach out to me and let me know what your experiences were with the rest of it. Send me the source code that you had to change to fix the leak, or, you know, whatever, you know, past comments. I'm quite keen on on getting your feedback and interacting with you, just so that you can get through the exercises, because I think that's where the value is. Obviously, in our time together, I want to interact with you as much as possible, but okay, for some reason, Eclipse is just not giving me any love, and Mission Control is giving me grief also. So I'm just going to shut this down again. I'm going to roll this back.
Yeah, the tooling is always a problem with these things. Unfortunately, there doesn't seem to be any perfect tools.
No, it's really frustrating sometimes. Simply because, well, I think this is still running the same version of JMC. Because I mean, you can do this 100 times at home, and then you get out someplace, and all of a sudden, it's like it's just going to start complaining for one reason or another. So what I can actually do is I can quit IntelliJ. I can exit. Hopefully that'll free up some memory. That'll let us continue forward.
Do you have time to try and solve exercise 2 or 3 or 4 or 5? Because we've got 5 exercises there.
I'm sorry, you're coming in garbly?
Do we have time to solve another exercise? We've got like 5 exercises.
Yeah, sure we do, because right now the way that the Eclipse Analyzer is I'm sure what I need to do is go down inside where the application is, get into the configuration file and say, hey, start with more memory. Because it looks to me the problem that we're having here is it just does not have enough memory for this particular heap dump to get through it quite nicely. And so it might be failing and retrying. I'm not sure what it's doing. So let's do that. And if I'm going to let this thing go for slightly longer because it is making progress towards 100%. But if it doesn't actually give me anything, I'm just going to shut it down, and we'll go on to the next exercise. Since JMC is giving us grief too, I'm just going to, where are we in terms of JMC? Oops. That's our flight recorder, mission control. Yeah, it must be just because my CPU is pinned. It's just not getting any time. Okay, so where are we at now? Oh, here we go. Excellent. Finally did finish. This is what I said. It just takes a time, and probably it's just because I could have backed off on the rate that was leaking, and I'd still get the same information, and the tools would be happier. So as the case there is probably too aggressive. So again, if I do the denominator tree, again, you can see the keyword comes right up on top here. So in this case, we got lucky. It's right up here, and you can see that it's recognized it. So I would say it's done a pretty good job, and you can see we can walk again back all the way through the data structures, and as we walk through the data structures, then we can actually again figure out what's actually happening. Okay, so you can get how things are connected. Again, you don't get where the allocation site is, but I think with this information you could go in and probably figure out exactly how to do that. Now, with the pain that it's actually taking me to get this thing to load, I'm going to hate.
Yeah, the last time we did this workshop, it didn't take so long. I think you just waited too long before setting the heat.
It's really weird, right?
Yeah,
and I used the same settings.
It was like a couple of minutes, and it was analyzed. And once it was analyzed, it's actually quite fast.
Yeah, exactly. There's our leak suspect report. Justin said, sorry?
What Justin says that he asks whether your kit isn't better because he says it gets much faster useful information than Eclipse or Visual VM.
Yeah, it still has this issue. If you don't give it enough memory, it just simply doesn't have enough memory, right? So I think that yeah, I mean it still suffers from those issues. right? You just need to give it enough memory. But yeah, it tends to be a bit more stable for whatever reason. It's not like Visual VM and Eclipse don't get the love that they deserve in terms of development time, but you know, it's different strategies from different people. So YourKit, JProfiler, yeah, I recommend it. You know, the thing is with these webinars is I'm not really trying to sell one tool over the other. And so I don't really include the commercial tools because I want things that are available to you right away. But I would suggest that, hey, take these exercises, and if you have a JProfiler license or a YourKit license, really seriously go out and there's just something completely messed up here. For some reason, I can't do anything. This thing is just all completely finished. What is still running here? Java is running at 581%, so something's happening. Yeah, so just really seriously take, oh, let's do this. Ooh, I don't want to do that. I think I might have just run this thing out of memory now, and that's why it's so let's just keep it paused like that and see if we can get through this part here. Yeah, just sort of do the exercises with those tools and just see what's going on. Okay, can I just work this without the? No, it's just completely hung, which is very frustrating. Okay. Let's see if I can just get around it. Yeah, the current version for Java Mission Control is 7, but unfortunately it's not suitable for this type of exercise. So you still have a bug in it for memory leak stuff. Okay, so anyways, so here's our web server, which unfortunately I have in the suspended state right now. So let me just, you know what? I'm just going to shut it down. I'm just going to kill it. Where'd it go? Oh, darn. Okay, then let's do, did I shut it down here? Is this where it's running? So that's in the background. That's %1. Okay, so that's not it. Where did it go to? Okay, get rid of Windows. Let's get rid of Windows. There's stop jobs. Okay, so let's just minus 9%1, and I'm just going to start it again. And I'm not going to put any load on it, so because we just want to go through the mechanics here. So, and again, there's a number of different ways that we can start this. So the one thing we need to do is we need to have this commercial features turned on. So up to 8, you're not allowed to use this in a production environment. In order to start a flight recording, it's going to complain. Okay, it's going to complain and say commercial features must be, we must unlock commercial features in order to do a flight recording. Do you want to unlock? So we can do this actually via JMX. So it's going to use JMX link to actually do this automatically for us. So don't worry about this. I could put this command, these things on the command line, and it would work. Actually, I could put these on the command line and put a bunch of other parameters down on the command line that basically says, you know, in 10 minutes, take a 1-minute recording to see what's going on. Dump that out, and then we can pick up that file and load it directly into JMC. So in this case, I'm going to do just a 1-minute recording on this whole thing, and maybe I should get something interesting happening here. So let's do JMeter. So we'll start the recording. So I don't really want to go into all the mechanics of flight recording, flight recorder specifically, but you can see what happens is that we can just say record the counter values for duration of 1 minute, and when we're done, what we're going to do is we're just going to load that. So let me go to here and let's get this to run. So it's going to do something interesting, hopefully. Okay, so now we're just going to wait a minute. Any interesting questions while we're waiting? That's the thing about benchmarking, right? There's lots of in a Docker container, like false positives, watch out for. Does it mean for Docker containers? No, it's the same deal, right? It's just your heap is leaking or not. There's really no gotchas, no false positives there. In other words, there's nothing in Docker that's going to mess with the JVM that much. Okay, so we're almost finished the recording. Okay, and as we finish the recording, what I'm going to do is I'm just going to kill that. And okay, cool. Now they did, yeah. So one of the things I complained about with mission control, actually, I didn't complain about mission control. Was complain about profiles. They just sort of like spit a whole bunch of data at you, and as they spit data at you, they, you got to sift through it and figure out, where is everything. And if you look at JMeter in particular. It used to be that you just got pretty much all of these views over here. So let's see if I can get this thing to cooperate. Make this view bigger. And so you just had to like basically randomly bounce around things, trying to figure out, okay, is this actually what I'm interested in? And so I think they recognized that this was a problem with a usability issue of the tooling, and it can be a usability issue for your kit. You get sort of focused on the wrong things just because you're looking at a profiler. A profiler is telling you something because that's what it's designed to do. It's designed to tell you something. And then you look at it and think, that's the problem. And it may or may not be. You just sort of need to figure out. So what happened is that they said, okay, this is a usability issue. And what they did was they got some people to actually try to do some analytics on this to see if they can figure out, okay, what's going on. So they're giving you some analytics saying like, okay, do we have problems? And they're saying, yeah, okay, so they have this big problem, which is like memory pressure. So at least in this particular case, you can see that there seems a lot of pressure on memory, which means that there's now a lot of pressure on the GC. So the JVM was paused for 66.7, that's impressive. Right, so that means 2/3 of the time we're in a garbage collection. I mean, a well-tuned collector should be running for far less than 5%. So just to show you how bad that is. We have a heap trend. The heap's constantly, so there's every indication here that there's some sort of memory leak because during the recording, we constantly had this, increase in heap occupancy. Yeah, and now this is where they go off, right? Threads in the application were blocked on locks for a total time of 2 minutes and 30 seconds. Concurrent hash map node, blah, 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 blah. And, guess what? These are threads, basically, these are Jetty threads that are idle, right? So that's a false positive. So this is where their analytics fall off because they looked at it and said, oh, we have all these threads blocked. So again, they're just giving you a whole bunch of different problems that are in here. Some of them are real, some of them aren't. Yeah, and so it's just really, the one where we know that we have a GC problem, like a memory leak. So anyways, so we can find it. So here we can go through the whole thing and you can see, hopefully they have data here, max live size, max live count. And at this point,
actually, that block could be an issue, because you've got all these threads hitting the same concurrent hash map, and on the right, that actually would be an issue.
Yeah,
it's not the issue. It's not the issue, but it
really isn't an issue. I mean, quite honestly,
it's not the issue. No, it stands out too strong.
I mean, we've tuned this application like right down to you wouldn't believe, and concurrent hash map access never is an issue in this application, no matter what you do to it, right? But you see,
right.
Yeah. So when we look at
you're writing to it from so many different threads at the same time.
Yeah, honestly, Heinz, I mean, the whole thing runs in, these queries run in well under a millisecond, you know, when things are working properly in here. So it's really not an issue. So again, so when we look at this, you can see what's going on in terms of it's really like, I don't know, it's not really my favorite view, but you can see a histogram as to what's going on over time with each of the objects here. So it's sort of like, I wish I could point it out, but it's basically this blue stuff in behind here. And so it's really kind of like funky, but you can see these guys with the bigger histograms and stuff like that are probably going involved with these are the things that are going to be involved with the leak. So things like this is not going to be leaking. So it's kind of a strange view of the data. I guess they're trying to be innovative, and it seems to be rather shall we say they have it's just lots of multiple views all at the same time, and I just find these types of views in my opinion are just fairly confusing. So you can see that it gets very difficult, in my opinion, to actually identify things in here. Now they do these things called like TLAB allocations, so you can look at allocation rates. Again, this really dives into a GC data structure discussion to understand what the TLABs are. But they do what's known as TLAB sampling here to actually help you understand what the allocation rates are. So these things are, shall we say, a one-off metric of allocation rates within your applications. Anyways, that's the type of view you're actually going to get from this tooling.
Kirk,
right.
A quick question. We've got another 2 minutes, 3 minutes, 4 minutes left before we need to wrap up.
Yeah, sure.
Where can we read more information about all this stuff? Where can I find something to figure out more?
About memory leaks in general, or just about heap and all the garbage collection and
memory leak, GC, whatever.
Yeah.
Any good resources?
Well, I think there is some stuff happening within mission control in terms of identifying memory leaks, and what it's called tenured sampling. There's some of that should have been out in JDK 10, but so Marcus Hurt actually has some of this information on his blog, and since he's really the architect of mission control, then you can pretty much guess that his information is going to be highly reliable. Nitzan Walker has a blog where his information is highly reliable. Each of the vendors have blogs that their information is. It's really funny. Some of the vendors had like if you read something on the YourKit or the JProfiler blog, I mean, good to go. There's some other people that write that their information is less than reliable. Ben Evans with a couple of guys, James and Mr. Newland, Chris Newland, wrote a performance tuning book that's by O'Reilly. I would consider that the most up to date. And I know that I had some long running conversations with Ben when he was writing the book on garbage collection. So, and I did some reviews on it. So I know that his information is technically correct in terms of the stuff in there in terms of how the JVM works. So I consider that to be a good source of information. Well, there's a whole bunch of questions coming in here. Is it possible to send us a set of good read blogs? Yeah, well, I can probably throw that together, and I probably should have. No, I wasn't. So I'm not going to talk about my tooling. It's a commercial tool, and I've tried to stay out of talking about commercial tools. I'm quite happy to talk to you after the fact in terms of it. Where can we read? Okay. Where will we find the recordings of Kirk's approach to solving the exercises? I'm probably going to publish them on VMO, and then I'll distribute the URL to them to you. But I'll make sure that they will be done very shortly. I was just trying to do some, so I should have it. Is there any place where we can learn more about OQL, Object Query Language, in Visual VM? There are a couple of blogs out there I can point you to. The OQL in MAT is different than the OQL in Visual VM. That's all I can say. So IBM does have some on DeveloperWorks. They do have some articles on OQL. I have a PDF that I can probably redistribute to you. That's basically a PDF of a blog that might not exist anymore. And that has some information about how to use OQL in it. I know that Heinz and I have successfully used OQL in finding actually concurrency bugs, strangely enough. So it is a useful tool. I don't really include it here because, you know, it's just a matter of time. In your experience, what's the least intrusive tool? JMC, JVisualVM, JCommand, or GC logs? I mean, for just understanding what's happening in heap, GC logs are the least intrusive. We do have some tooling that will allow you to live stream GC logs so we can look at analytics. We're currently talking to a company that might sponsor us to actually build this out into some sort of different type of stack that might make it more visible to different projects, like an elk stack or something like a visualization stack. Right. Containers and stuff like that. Okay, so, or custom mbeans. You don't need custom mbeans to look at memory. You will need a client. Just let me very quickly show you some of the code, and I should put Leaky out on GitHub, and then I'll put it out in an open repository, so you can get it on my GitHub account. Okay, close that, and let's drop this down. Interesting. Should be in here. Right. Okay. Sorry. I'm just looking, trying to figure out where it is. Okay. So here you are. You can see I get management factory, get memory, MX bean. Here, get heap usage, get use. And that's really all I'm doing here, right? And in this case, I'm just adding it to this date chart that's actually now FX is magically then popping that data up onto the up into the screen. So then this is all managed by a timeline. So every second sample display the value. Okay, so that's pretty much what it is. So you don't really need a custom MX bean for this one here. Yeah, okay. Now, I mean, you can put in your custom mbeans, and I do tell people how to do that, and that's certainly, that's in my 4-day workshop. But yeah, it's just a really simple thing to do. Okay. Are there any more questions? Oops. Turn off notification. Thanks. And thanks. Okay, nice. Okay, I don't actually see any more questions. Heinz? I'm not sure where Heinz went to.
Quickly. Mine is still getting problems, but
No, Manny says yes. Well, that's Manny's job.
he'll figure it out.
He's supposed to find. Minus XX colon plus. So you need a minus there.
So what's your next workshop about? Anjan wants to know.
Yeah, so I think it's minus XX colon plus, right, on the flight recorder thing. So yeah, so on the XX flags, you have value and you have binary, right? And so these are binary flags, which means you need the plus for true, negative for false on them. The value flags will have equals and then some value attached to them. In that case, you wouldn't use the plus or minus. Just to make that clear. Okay, yeah, so that's Manny's job. His job is to actually find as many problems as he possibly can. And we appreciate that. Okay, I don't see any other questions coming in. I don't know if anybody else has questions.
I think we're done.
Sorry?
We're done. Thank you very much, Kirk, for doing this workshop for us.
Look, guys, I really appreciate your time. I'm going to apologize for the first demo at the beginning failure, but I think the rest of it hopefully went reasonably well. Again, I do encourage you to get the most out of the workshop. I think it's very important that you do the exercises on your own and send me information. I think you have my email address at kirk@codework.com.
Yeah,
you post it perfectly. And yeah, even if you want to ask me a question about a problem that you're having that's not related to the webinar, feel free to reach out. I'm quite happy to try to answer any questions that's related to all this material. Okay. And that's all I have. It's the beginning of the week, so have a great week. Go find some memory leaks and knock them out of your system. Improve the stability of your system.
Absolutely. Thanks, Kirk.
Yeah, thank you, guys. And we look forward to hearing from you in the future with your progress on the exercises. Okay. And with that, I think we can
say goodbye.
Say goodbye and have a great week, everyone.